how are you all? Welcome to the demo day. Finally, we are at the demo day of this Google Summer of Code 2024 at the Liquid Galaxy project. So let me make a brief introduction. First of all, of course, I have to say thank you. Thank you to all the contributors, the dozen contributors we have this year working for the project, to all the mentors, a very large mentors team. Let me take this precious picture I have here with all the faces, the lovely faces of the students, mentors, and other contributors. And let me say their names. We have Mahinour, Rofaida, Ryan, Rohit, Siddhar, Manoj, Oscar, Gerard, Davit, Mattia, Aritra, and Shiven. They have been the 12 contributors. And then we have Claudia, Laura, Paula, Irene, Emily, Lucia, Alba, Vertica, Saumia, doing some stuff as mentors. Alejandro, Oscar, Vedant, Yash, Prayak, Merul, Gabri, Otavio, Alfredo, Mario, Victor Carreras, Victor Sanchez, Moises, and myself, Andreu. And then also we have some other people that are helping us during the last months. We have Jordi, we have Mark that is just behind me, Basilio, Josep, another Mark, Hector, Oriol. We have very repeated names this year. And Heath, Pleshan, Deb, Shashwat, Atarra, Om, Ashutosh, Pablo, and Gucci. So thank you all the big team of collaborators and contributors we had this year. So it's been a long summer. And we know the typical phrase, life happens. We have some personal problems, some of you have issues in your own life, some of you have medical problems, some of you have coding problems, of course. This is a coding experience. It happens that in midterm, everything was well, and suddenly after midterm, all of you were okay, and suddenly after midterm, plenty, I will say, 40% of the projects went down, suddenly they didn't progress, and some of them were in a very bad shape till last week. There was a couple of projects, still there are a couple of projects that are just in the 5, so very just. Hopefully they change their mind and they make a last effort this week and they solve their problems and we repair whatever things it happens. So also I have to tell you that in the very beginning we talked about that this year is going to be special because we have the Liquid Galaxy AI experience, trying to use the different models on the market, using on our local AI server, using on external APIs and so on, also implementing this artificial intelligence voices. This has been a little bit difficult. Even it happens at some point that we try to use GEMMA locally in our servers. We do that in the past, but suddenly this year it's not happening as right because the model needs plenty of hardware and needs a change of way that the students, the contributors made the code. So it finally happened. We didn't succeed, and we make a new approach. Is that instead of going to GEMMA local, we went to GEMINI on API, and suddenly everything happens. We have students that took 10 minutes to get a result. This was totally unacceptable. And after this, of course, they are in the seconds, 5 to 10 seconds. That is great. So it's been a research thing for all of us. Thank you for the students that have changed their minds and with the mentors for preparing this thing. And also I want to say that hundreds of meets have been doing in these past 3 months and the 4 months with a very large team of contributors. And also we did a very good job on training you, all the community, the contributors and the rest of the community on doing the streaming we have done in the past. Many of them we have the complete list on our website, liquidgalaxy.eu, because we thought it's very important for you as contributors in GSoC and outside of GSoC. They train and we bring some of Google developer experts with very deep knowledge on artificial intelligence, Flutter, and many other questions. Even lots of students contribute with sharing their own experience in other soft skills or hard skills or coding skills. And I think we did a very good job here. So I hope you have a very good experience this summer. I hope you all enjoy it. Next September 3, we will know the final results from Google. It's Google who has the last word, except Oscar that is giving us some sounds now. And So good luck to all of you. Thank you for contributing this year, and see you soon.
I'm Basilio, the contributor of Linky Galaxy Lab in Lleida, Spain, and we have our Linky Galaxy ready to test your Google Summer of Code applications.
Hello, I am Mark, a contributor at the Liquid Galaxy Lab in Lleida, Spain. We have our Liquid Galaxy ready to test your Google Summer of Code applications.
Hello, I'm Victor, a contributor of the Liquid Galaxy Lab in Lleida, Spain. We have our Liquid Galaxy ready to test your Google Summer of Code applications.
And we will explain some issues that may happen during a real Liquid Galaxy Rift installation.
Hi, I'm Mark, a contributor from Lleida, and I'm going to explain you some things about Ubuntu and Liquid Galaxy's installation. First of all, during your Ubuntu's installation, you will have to put LG as your name and as username. Also, in computer's name, you will have to put LG plus the number of the machine. This computer is the master computer, so you will have to put number 1, LG1. Also, as password, you will have to put the same password in all computers. For example, you can use LQ Galaxy. And all the users must log in automatically.
Hello, I am Jordi, a contributor at the Liquid Galaxy Lab in Lleida, Spain. We have our Liquid Galaxy ready to test your Google Summer of Code applications.
Hello, I'm Oscar, a contributor here in the Liquid Galaxy Lab in Lleida, Spain, and we have our Liquid Galaxy ready to test your Google Summer of Code applications. And I'm going to show you two issues that we have during the Liquid Galaxy installation and the progress of configuration. In here you can see that it says enter passphrase for the SSH. You don't need to do this, you just need to press enter twice, and this only shows for the master. The command to put the Google Earth in full screen it has to be when the Google Earth is like this. It shows a bit of the Ubuntu background and not the full screen on the Google Earth. The issue that I'm going to tell you now is a post-installation issue that happens if the Google Earth doesn't open, that should open after the installation if you did a correct job. If it doesn't open and you put the next command, if you put this command, the issue will be that Google Earth is not open. You will put this command. This command works so that the Google Earth is open in full screen at all times. But if you put it and the Google Earth is not working, it will crash your screen and fade it to a gray color.
So, community, contributors, mentors from around the world. We are the Liquid Galaxy Lab laboratories in Lleida, Spain, as our colleagues have shown you. And then we are almost ready, and
we are ready.
For what? For this summer, testing your Google Summer of Code applications. Take care, see you, bye-bye.
Everyone, my name is Mahinour Elsarky and I'm very happy to be here today presenting my final demo in the final demo day. And this journey was amazing and it was filled with many challenges that, of course, with the help of the community and their support, I was able to pass them all and be here today presenting my demo. My project was AI Touristic Information Tool, which facilitates the travel experience for the users. So it can help them discover points of interest tailored to their preferences. For example, discovering touristic information worldwide or in a certain location, or for example, best shopping places, best dining spots, and many more activities they can find nearby or in a certain location they want all around the world. So of course, those points were generated using AI. In my case, I used GEMMA and GEMINI AI models both. So at the start, the project was originally tailored to GEMMA locally. And first, by the end, after solving many challenges, I was able to make it work through the Docker container. And it was hosted successfully in the AI server in Lleida lab. But since it was giving slow results in like 10 minutes response time. That is why we decided to use GEMINI API since it's faster. It solves like in a few seconds. So this is why I switched to GEMINI at the end. But for my project, I worked with both AI models and I got to gain the experience of working with both of them. First, let's dive into some technical experience about the application. Then I will show you some small demo about my application. So my project mainly included technologies such as Flutter and Dart for the mobile application, and for the AI integration I used GEMMA and GEMINI models, and I also utilized LangChain, Ollama, and Docker. So let's start with the AI integration. As I said, I used Ollama for the model and the Ollama embeddings. And one of the reasons I used LangChain is I wanted to chain the model with other things, such as, for example, because the GEMMA model didn't output good results or up-to-date results, and this was a problem. So I thought of using a RAG technique, which is retrieval augmented generation, instead of fine-tuning the model. So to do that, I have web scraping first to gather by Google search some URLs, and I only fetched 10 of them. And after that, so this is the first step. And after that, I loaded using async Chromium. And after some processing and splitting, I used the Chrome for the vector store, and I used this retriever using similarity search. So in our chain here, we can see that I have the retriever, and this is our LLM. I also chain it with the prompt and the parser. Prompt is very important to instruct the model correctly to avoid hallucinations or any unexpected errors. So after that, of course, we need to make it available for the Flutter application. So I thought of using the Fast API, but since I'm already using LangChain, I have the LangServe. Since LangServe already works with Fast API under the hood, I also have two other endpoints to check if the container is already running and the model is accessible, and for fetching the URLs. So this is mainly here the code, and of course I reached this after many trials. And last thing, because I want this app to work in any other environment and on any server, so I made this image which I pushed into the Docker registry. So this was used in the AI server in Lleida lab, and it was run successfully after many trials. I made a Docker manual so everyone can access the Docker and run it successfully. So now I'm going to dive into my Flutter application. I have it in a clean way so it can be done in a larger scale later. So I have here all my dialects in the UI that I need, so as follows. And here I have the helpers to save the data locally. So here are the favorites for the places or the tours that the user saved, the LG connection data, the prompts, the pre-made prompts that give the user an indication that he's using an AI. This is also the settings for saving the settings of the user. Those are the keys, the global keys for showing an in-app tutorial for the user. We also have a localization for showing different languages, up to 8 languages for the user with all the text here, different languages, and this is everything. So here we also have the models Those are the KML models that are used with their properties and their tags, so they can be used later, and this makes the code much more cleaner. We have also here the look at for the tags and the properties. Same here with the orbit around orbit function, which makes an orbit 360 degrees. We also have the place mark with all the data it needs. We have the point model, the screen overlay model with the balloon tag or the normal tag, and those are its properties. We have the tour model. We also have here the models for each model that we want in our app. For example, we have the places model here with all the data that we need. So all of them are just some models that are used later in the app with the SSH model too. So next we have the reusable widgets. So those are all reusable widgets that I use in all parts of the app. So this is much cleaner way to do it. So we have also the screens. We have those main screens about the settings, favorites, home, LG connection, LG task view, and splash screen. And here are some views which are the dialog views or the tab bar views. This is also state management for all the providers I have in my code. So this is for the state management. We also have some here. The mainly important part here is the KML builders, where I build all the KMLs of my application using the models I just showed you here. So now one of the most important two files are the GEMINI services and the GEMMA services. For the GEMINI, I did exactly what I did in the Python code using LangChain package in Dart. And first I have to check the API validity by running a test query. And here I have the generating stream, where first I do the exact same, fetching the URL, the retrievers, and here's the same prompt. The parser, maybe some small differences, but it's the same process. And this is also the streaming, where I yield different messages according to if it was streaming or if it was done the streaming or whatever. So this is for the GEMINI services. For the GEMMA, I also have functions to check if the endpoint is available or is the server available. This is also a streaming method. So since the API call or the endpoint is already streaming events, so here I yield also some data. Here we have the GE coding services to get address from the latitude or longitude or to get the coordinates. We have the KML file services. We have the LG functionalities. We have a search services to search the YouTube or to fetch URL. We have also voices services to speech to text and text to speech. So this is mainly everything important in my Flutter application, and thank you.
So this is the app, and here we can see that the user can choose one of the worldwide touristic recommendation or type his own prompt. He can also explore anything nearby his own location using the navigating through the map or typing in a certain address, or using the map only to navigate and show the relevant street in the map underneath. And then he can choose any of the AI recommended things to do nearby. So for example, let's choose local parks. We can see that the AI generation is collecting data from the web for accurate and up-to-date experience. We can see that now it's generating the points. It takes about 20 to 30 seconds. Now it's preparing the visualizations. And now we can visualize. We can see all the points here. We can see them on the balloon too. We can also fly to a certain location. We can see that we have here the balloon with the details, and here too, the Google map and the liquid galaxy. We can orbit, and we can stop the orbit. We can add this to favorites or remove it from favorites. We can play a tour, but let's first clear the data. And the tour basically just goes to each location, orbits around it, and goes to the next location, and so on. And of course shows the relevant balloon beside it. We can stop the tour. So this is the settings page where we can choose to different appearance, and whenever we choose a different appearance, it's going to reflect also to the KML balloons. We can choose also here a different color. We have also a light theme and a dark theme, and we also can change the font size, and all this will reflect also on the KMLs, as we were going to see later on. And here we have some information about the Liquid Galaxy and the API keys. Here's the place where we can add an API key or edit it or view it or delete it. Here's some help or guide for the user for different guides to guide him through the app. And this is also a language reference where the user can choose more different languages. I have up to 8 languages in the app. Now we can see that the language has changed. We also have the about page with all the logos. We have the LG text and the connection screen. And let's go to the favorites screen. This is also another feature where the user can see the customized tours or the ones generated by Gemini where he saved as favorites. So we can see here or visualize it as we did before. Let's close it. We can see also the balloon change its color based on the theme. We will have also here a customization where the user can customize his own tour by the favorites places he has saved. So the user can click on, it has to be at least 2 or it will give an error. So he can choose more than 1 and then customize. Here we have also a guide if the user was having troubles following what to do in this page. We can drag and drop into the map. We can reset or we can create a tour. So let's create a tour. We can see that it's created both here and here, and we can see the balloon with the custom tour pathway. So let's start and visualize it. It will visualize in Google Earth and Google Map both. We can also stop the tour. We can save it if you want, or we can just close it. So this is mainly the most of the features I have in my app, and thank you. Lastly, I want to talk about my experience this year with Google Summer of Code with Liquid Galaxy organization. Being selected this year was an amazing opportunity for me, and it made me grow personally and technically, especially in the field that I'm passionate more about, which is AI, by leveraging Google generative AI models, GEMMA and GEMINI in my project. This project was one of the most challenging projects I've ever worked on in my life. And this was because of many reasons. One of them is because of integrating GEMMA locally and hosting the Docker container. Due to the complexity of how I managed to do the architecture of my project and how the flow goes, I couldn't find much resources online of helping me fix my issues. And it was very challenging to me, as well as the Docker process with all its challenges. And of course, after all this, I also had to move to Gemini at the end and refactor the code for this. So because due to the slow response time of GEMMA. So all these were the kind of challenges I faced in my work this year. And I can say that with every challenge I solved, I feel more confidence that I can fix anything and can solve any obstacle I fall into in any project I work on. Of course, I wouldn't have reached this without the help and support of all the Liquid Galaxy community, starting from Andrew, the Liquid Galaxy admin, and from my main mentor, Claudia, and from my co-mentors, Irene and Emily, that helped me and gave me so much valuable feedback along the way, as well as Oscar and the Liquid Galaxy lab tester that helped me go through the testing process and uploading my app to the Play Store. So thank you for all the Liquid Galaxy community for their support, and thank you.
Hello, my name is Claudia and I'm a full-stack developer at Origin Studio. My journey with Google Summer of Code began years ago when I was a student at Liquid Galaxy Lab. Since then, I've had the pleasure of mentoring for 3 years in a row. This summer, I mentored Mahinour Elsarky on an exciting AA project, and it turned out to be a great experience for both of us. This is actually my second time mentoring Mahinour. Last year, she worked on bringing new life to a project that I had created when I was a GSoC student myself. This year, we continued our collaboration on a new project. Every week, we met to discuss her progress, and Mahinour always impressed me with her well-prepared presentations. She clearly explained any challenges she faced, the creative solutions she came up, and her plans for moving forward. Midway through the project, Mahinour encountered a major challenge that required her to change her approach. This was a big shift, but she handled it with determination and grace. It was inspiring to watch her adapt, learn, and continue to make progress despite the obstacles. For me, mentoring Mahinour wasn't just about offering guidance, it was also an opportunity to learn. Although I've been a developer for some time, working with Mahinour on this project introduced me to new ideas and ways of thinking. It reminded me that there's always something new to learn, no matter how much experience you have. Reflecting on my own journey from a GSoC student at Liquid Galaxy Lab to now being a mentor for 3 years, I'm deeply grateful for this experience I've had. Each year has brought new challenges and new learning opportunities, and this year was no different. In conclusion, mentoring Mahinour during this GSoC project has been a truly rewarding experience. I'm proud of everything she accomplished, especially how she overcame the challenges she faced. I'm also grateful for the chance to be part of her journey. Finally, I want to express my gratitude to GSoC, Liquid Galaxy Lab, and Andreuibanez for giving me the opportunity to grow as a mentor and as a developer. I'm excited to continue this journey in the future. Thank you for listening.
Hi there team, I'm Emily, a computer science student at the University of British Columbia and current software engineering intern at Stripe. I've been involved with Liquid Galaxy since 2019, when I was selected as one of Liquid Galaxy's Google Codin Grand Prize winners. Google Codin was an open source competition aimed at introducing teens to open source, and I'm so glad I had the opportunity to connect with and contribute to Liquid Galaxy then. Since Google Codin, I've been co-mentoring Google Summer of Code projects each summer, and I've had a blast working alongside so many talented students developing such creative interfaces to the Liquid Galaxy. I think this summer is my 3rd or 4th summer co-mentoring with Google Summer of Code. And this year, I've been helping review, test, and provide feedback on Mahinour's LG GEMMA AI Touristic Information app, which connects AI-generated information about a city and its points of interest to the Liquid Galaxy rig, so you can explore interactive tours of so many incredible places. I've only tested Mahinour's app a handful of times, but each time I'm impressed by the quick progress she's made and how much the app has changed between tests. What really impressed me is her app's customizability, its theming, and accessibility features. I think this is the first Liquid Galaxy app I've tested that can respond to system theme configuration and that you can change the appearance of, as well as has several font size options, which really raised the bar in terms of the design and basic feature set of our GSoC apps, so really well done there. I know there were some challenges with setting up the app servers and eventually requiring this migration to GEMINI instead of GEMMA, but I think Mahinour managed to pull it all off really well. She also did a super great job actively addressing feedback and integrating it into the next versions of the app, and I'm really looking forward to her demo. I also briefly tested Ryan's LG AI Voice Conversation API, which connects several open source large language models and voice models to the Liquid Galaxy. His documentation was very extensive and thoroughly researched, and I think most of our GSoC apps would do well to aspire to such a standard. The API was easy to set up, install, and use, and I'm also excited to see what he demos soon. I'm glad to have the opportunity to check in with our GSoC students and be a small part of their open source experience this summer. And I can't wait to see how these projects wrap up, not only for GSoC this summer, but how they'll continue to evolve soon in the future. See you!
Hi, I'm Rufaida, and today I want to share my journey with Google Summer of Code 2024. The idea of contributing to an open source community, connecting with different people, and expanding my knowledge was incredibly appealing. When I started engaging with the Liquid Galaxy community, I was met with amazing support from everyone, including the admin Andreo, mentors, previous contributors, and those aiming to apply this year. What I loved about it was the chance to start contributing even before being accepted to GSoC, which was a fantastic learning experience for me and everybody. Aside from the technical aspects, one of the biggest challenges I faced was organizing my project timeline and crafting a solid proposal. Starting a project from scratch can be daunting, especially when you are unsure of what to prioritize. Thankfully, my mentor Oscar was there every step of the way. He provided invaluable guidance, ensuring I stayed on track and offering multiple solutions whenever I encountered issues. Reflecting on this experience, I'm proud of how I handled the challenges and brought the project to completion. My biggest advice to future GSoC participants is to start contributing, even if it feels overwhelming or you are unsure where to begin. I first heard about GSoC in my second year of university. I was eager to join before graduating, but fear and doubt held me back. And I kept postponing it, thinking I wasn't ready. But the truth is, just starting is the most important step. With time, the path becomes clearer, especially when you are part of a supportive community. GSoC has been a pivotal experience for me, shaping my career plans, and it's something I'm always proud of.
Hi everyone, I am Rufaida, and in this video I will be doing a code review for my app completed for Liquid Galaxy and GSoC 2024. During this period, I was able to develop the AIS visualization. The app is designed to provide real-time tracking, detailed vessel information, predictive route analysis, and collision risk management. It is optimized for Liquid Galaxy systems, allowing seamless synchronization of maps between the rig and the app. The app can also function standalone, providing maritime insights based on the OpenAIS data from the Norwegian Coastal Administration. The key features include real-time vessel tracking, detailed vessel information, historical route playback, future route prediction, and collision risk management based on CPA and TCPA calculation, and finally, a customizable region monitoring focusing on specific area and filtering the vessel by type. I would like first to start by giving a quick overview on the app workflow. The app basically consists of two main parts. The first part, the one responsible for data retrieval and pre-processing, and the second one is the visualization logic. Let's start by the data retrieval and pre-processing. We have the main API for the AIS data provided by Brand Swatch for the Norwegian Coastal Administration. After we have done with retrieving our token and our credential, the app starts first by fetching all the data for all the vessels, and then it notifies the listener so that these vessels are added on the map. Then it opens a stream in order to be able to update the vessel location during the runtime of the app. After streaming these vessels, the data should be deserialized. Then we update our dictionary for the vessels, and then we re-notify listener, and these loops continue during the runtime. Then we have another part responsible for the selected vessel. It starts from the visualization logic. Once the user selects a new vessel, it gets reflected on this function, and this function updates the MMSI and refetch the new data for the new MMSI. After that, it opens a stream for that specific vessel and notify any listener or any signal for the UI. Then we have the route prediction service or the KNN service. It also uses the AIS API in order to retrieve all the vessels who are close to the selected vessel or the vessel inside the bounding box for this vessel, and then it works on calculating the similarity measure that will be explained later, and then update the UI in order to draw the flowchart. For the collision management service, we don't interact with the AIS API. We rely on some calculations in order to see how risk two vessels can collide. Now let's move to the coding section. In this code review, I will walk you through the structure and key components of my Flutter app. Let's start with the initial folder structure. First up, you have the utils folder. This is where I have organized all the utility files like theme, text, and styles. These utilities help maintain consistency throughout the app and make it easy to manage global settings and styles. Next, let's move to the screens folder. Inside, you will find the main screen of the app, which plays a crucial role in rendering the user interface. The main screen contains a stack of 3 key components that are rendered based on user selection: the left sidebar, the right sidebar, and the map in the center. The left sidebar handles navigation, allowing users to switch between different sections of the app. Right sidebar displays content relevant to the selected navigation option. The central map renders based on the current mode, either drawing or showing. The show mode is a default state, displaying the map for regular interaction. Now let's dive into the sections folder. Here we have the credential section, which is connected to the authentication service. Moving to the authentication service, the service is a singleton, ensuring that only one instance is created during the app runtime. You can ensure it here by this constructor, which always returns the same instance every time you try to call it. It securely manages user credentials, generating a token that is valid for 1 hour. This token is then used by the AIS service to fetch various APIs. This is what I'm going to show it later. But as you can see here, to get the token, you just call the brand switch API and it returns the barrier token. Before we explore the AIS service, let's take a look at the map component, specifically the marker clustering feature. This part of the app was particularly challenging. Initially, I used OpenStreetMap for rendering the map. However, with up to 4K vessels, to display rendering all these markers made the app lag. One key issue with OpenStreetMap is that the map re-renders every time you move it, which causes everything to reload, leading to performance issues. So I switched it to Google Maps. While I initially encountered a similar issue with markers, implementing clustering significantly improved the performance. The app now runs smoothly even with thousands of markers. The libraries that I have used to make this cluster, you can find it in the YAML file. Flutter, this is the one for Google Maps, and the cluster manager, this is the one for the clustering. Now let's look at the AIS service. This service includes several functionalities, each responsible for interacting with different APIs to fetch and display vessel data. Here is an overview of the key functions and how they work. Also, this service is a singleton service. It has a client. It also has a stream controller. This is the one used for streaming all the vessels or streaming a single vessel. We have 2 main functions. The one that cancels the stream subscription. Whenever you select a new vessel, you want to cancel its previous subscription and create a new one. Then we have this fetch initial data. It gets all the data of all the vessels. This response is then get decoded to map to the model called vessel sample. Here we have two models for the vessel. For the one that has all the infos, and the other it is sampled. The one sampled is used to be rendered on the map. Then we have the stream vessel data. This part is for pre-processing the data when it comes from the stream. Decoding the stream data was a bit challenging for me to be able to produce the exact format of the vessel sample model. Then we have another function that fetch a specific vessel depending on its MMSI, and we also have another function that stream a specific vessel depending on its MMSI. In this case, we need to cancel the subscription of the previous vessel and create a new subscription. There is also the function for fetching the historical data and one for the filtered data. The filtered data can take two parameters, one for the ship types and the other for the region coordinates. Then we have another function that is used for fetching the AIS data in a specific area used in the KNN model that we will see in the next part. But first, let's go to the LG service. One of the challenging here was dealing with very large KML files when uploading it to the Liquid Galaxy, because sometimes this file get interrupting, causing issues, and the file cannot be rendered on the LG map. To solve this, I have implemented a solution where the KML is sent stream by stream. This approach prevented interruptions and ensured that the data was transmitted successfully, even with large files. Now let's move to the KNN service. Moving to the KNN service, this class implements a key nearest neighbors approach to find the most similar vessels based on their spatial distance, speed, and course. This will be used for the predictive feature. It calculates the Euclidean distance between vessels and normalizes this distance to compute a similarity score. The predict method uses this score to identify the top K vessels that are most similar to a given target vessel. Additionally, the service can predict a future vessel location based on historical data using sample trigonometry. Moving on to the collision service, this class is designed to predict potential collision between vessels. It calculates the closest point of approach CPA and time to CPA by analyzing the relative motion between two vessels. The results include not only the distance and time at the closest approach, but also the exact location of potential collision. This helps in identifying preventing possible maritime accidents. Moving to the models, we have a folder for all the KML models I have created in the app. For me, the most challenging one was the Orbit Path Placemark KML model. This is where we create the orbit on KML based on the historical timeline. First, the timeline track extracted from the API. It has some redundant points, so I have used the Harvesian distance to try to make the path smoother as possible. Then I started building the animated update and the fly tool to be able to keep updating the place mark and deleting from the old place and add it in the new place, and to finally have a trajectory for the vessel with a good visualization on the Google Maps. And now I'm done with the code review. Thanks for your listening, and I hope it provides some insights on what I did during the 2 and 3 months of GSoC. Hi everyone, today I'm excited to walk you through a demo of my app for GSoC 24 and Liquid Galaxy, designed for real-time maritime visualization. Let's start by taking a look at the About section. Here is a brief explanation for the app key features. Once you click Get Started, you will be taken to the visualization section, but since you are not yet connected to BrandsWatch, the service that provides the current AIS data for ships, the app will prompt you to register a client. Here is how you can do that. Once you are connected, the app will display all the vessels in the Norwegian Sea region with ship markers and polygon for the sea. One of the features that really enhance the map's performance is the cluster effect. This keeps the map smooth and responsive even when there are a lot of vessels to display. Now let's move to the connection to LG section. Once connected, all the vessels appear on the Liquid Galaxy and the map synchronizes seamlessly between your app and the LG rig. Back in the visualization section, you can select a vessel either directly from the map or by entering its MMSI. Once you select one, the LG moves closer to the ship, showing the information balloons. You can orbit the vessel and take a tour for the Norwegian coastal region. The vessel information is organized into panels, as you can see here, making it easy to access all the details. Now let's explore the timeline track section. Here you can select a start and end date with up to 14 days of previous tracks available. You can even place the track on the map or on Liquid Galaxy. Next, we have the prediction panel. This feature allows you to predict where a vessel will be in the next 30 minutes. But keep in mind that predictions can only be made for moving vessels. Vessels with a speed of less than 0.5 knots are considered stationary and can be detected or predicted. Moving to the filter section, you can filter vessels by type. The app supports up to 70 types, and you can easily search through them to find what you need. Next is the Select Region feature. Here you can freely draw on the map to display vessels within a specific area, which is useful for focusing on particular regions. You can find here the LG services or tasks, either relaunch, restart, and others. Finally, let's check out the collision feature. This tool alerts you if two vessels are on a potential collision course in the future based on their CPA and TCPA, and here is a deep explanation of how each number means. That wraps up our demo. I hope this walkthrough be helpful to you and you enjoy using my app for all the maritime activities in the Norwegian Sea and Liquid Galaxy.
Hello, I'm Oscar. I've been a contributor for the Liquid Galaxy project since 2017, and this year I decided to also participate in the Google Summer of Code for Liquid Galaxy as a mentor. At first, I didn't want to completely commit to the project, so I kind of decided to be a secondary kind of mentor and assist the rest of the contributors and other admins to complete these years of Summer of Code without any issues. But this one day Andreu asked us that we should try and create maybe some project proposals so that students, future potential contributors, can decide whether or not to use those as templates or fully make a proposal based on them. And I had two ideas that I wanted to contribute. So the first one was to make a Risk kind of game where you could maybe play with your friends in the Liquid Galaxy and conquer different countries with KML, so you could showcase everything visually. I think it would be cool. But I had also another idea, and this one was, I think, more feasible but also more interesting to display. And that idea was to make an AIS visualizer. For those that you don't know, AIS is an identification system for vessels, for maritime vessels, so you can track different positions in real time for maritime ships and other kinds of objects in the sea. And well, so when I proposed both projects to Andreu, he told me this second one, the one with the AIS localizations, is way better than the other one. So I prepared a proposal for this one. I presented it in one of the live we made before starting Summer of Code, and I got one student that wanted to participate on it and made a proposal. This is Rofaida, which so far has made a really amazing project. I'm so convinced this is one of the best projects I've seen someone made. And personally, I didn't want to commit that much to doing things in Summer of Code, but I thought, well, this is actually something promising. I think I can actually help a lot to someone that wants to make this project, and I also think that this is a really cool project. So in the end, I actually decided to mentor Rofaida on this, and well, so far it's been an amazing experience, and I'm completely convinced as well that Rofaida has been following each suggestion and tips and everything I suggested to her in a really amazing way, and she's totally prepared to finish the project in literally, I think it actually looks pristine, so well, see it for yourself.
Okay, so let's talk about the app goal. The goal of this project is to build an application called Space Visualizations for Liquid Galaxy, designed to provide an immersive space exploration experience. The application has two main parts. The Mars 2020 NASA mission section lets user explore the Mars mission by viewing and interact with 3D models, important data, some technical text, and the paths of the Perseverance rover and the Ingenuity drone. Users can also see Mars from the rover's perspective, with access to over 220,000 photos provided by NASA. Now let's see the Earth orbits. In this section, users can learn about the famous Earth orbits. These orbits are shown both in the application in a 2D map, but also in a realistic way on the Liquid Galaxy Google Earth. Users can interact with these orbits and learn more about them. The application uses the Liquid Galaxy platform to make learning about space mission and Earth orbits more engaging and immersive. Now let's see the technology used. I used Flutter and Dart to build and develop the tablet application.
I use KML for display drone and rover path on the Liquid Galaxy and also on the application map. The rover and the drone path are generating from the official NASA website as a GeoJSON format. Then I converted this file and improved it in a KML format. Those technology that is KML is also used for display the Earth orbits. But at the moment let's see Python. I use Python because those orbits, KMLs, are generated from the TLA orbit data using a Python script. A TLA, a two-line element sets, is a data format encoding of a list of orbital elements or of an Earth orbiting object for a given point in time and in a epoch. Those TLA are public online on sites like NASA and Chu.io. Now let's talk about Node.js. To display the rover photos images on the Liquid Galaxy screens, I implemented a service that divides the images into sections and then display the images selected relative to the screen position. Now let's see Bash scripts. I use also some SH scripts to manage the Chromium pages of the Liquid Galaxy from the tablet application, so the application can manage, so close, open the Chromium page remotely. I also create a script for the installation process of the display images service. The Node.js service is used to display the rover's photos on the Liquid Galaxy screens. So, what are the libraries in Dart used? I used Dart SSH2 to manage the connection, the SSH connection between the application and the Liquid Galaxy rig. I used shared preferences, that is a library used as a persistent storage for your application, so I stored the persistent variables. I used the Google Maps Flutter library to display the Google Map widget in the application. I used the WebView Flutter, that is a library used to display web pages in the app, used for learn more buttons and functions. In general, it displays the relative NASA page with more information about the topic. I also used Model Viewer Plus, that is a library used to display the rover and the 3D models in an interactive way. I also used the Showcase library that is used to build and implement an onboarding process. It manages the animations and the order of this onboarding. I also used in the last the HTTP. This library is used for the HTTP request, used for managing the API request, particularly for the Nice API. Okay, so here we have the Nice API class. Let's start from the isAPI-keyValid method. This method checks if the provided API key parameter is valid or not. It does this by making a request to NASA server. If the server responds with a successful message, the key is valid, otherwise it's not, so it returns true or false. Now let's see the getAPI-key method. This retrieves the API key stored in the user's device using shared preferences library. If the user hasn't inserted any API key in the settings page, the method returns a default key. Now let's see the getMissionManifest method. This retrieves a list of active days with mission information, such as the total photos taken on the day and the number of cameras used on the day. It sends a request to the server, and if the request is successful, it returns the information in the form of a map. Now let's see the getPhotos method. Okay, this method gets the photos taken by the Perseverance rover on a specific Martian sol day, passed as a parameter. It sends a request to NASA servers with the sol number as a parameter, and if it's successful, it returns the photos also here as a map. Now let's see how I implemented a cache method to avoid unnecessary API calls. Let's start from store manifest in cache. This method saves the mission manifest data into the device storage. as a cache, so that it can be quickly accessed later without needing to contact the NASA servers again. So we are avoiding unnecessary API calls. Now let's see load manifest data. This method returns the mission manifest if it's saved, but if it's not saved, it fetches it from the NAS API and then it stores the results in the cache for a future use. We have also a clear cache method that removes the cached mission manifest data from the device. This is used if data stored in the cache are outdated or no longer needed. Okay, so let's talk about the orbits KML. The orbits are generated, as I said before, from a Python script given a TLE. Those orbits follows the same KML scheme, but with different line coordinates. So we have two methods. There are load polylines and parse KML from assets that convert those KML's coordinates into polylines that can be displayed natively on the map widget in map flutter library. So let's see the code. Here we have the orbit page with one particular function that is parse KML from assets. This function parse a KML file from the asset bundle, so the asset folder, and extract the coordinates to create the path. It returns a list of lat long, that is a class that identifies a point on the map. So a list of those points create the path. So first, this method loads the KML file as a string from the asset bundle. Then it initializes an empty list to store the parsed coordinates as a lat long objects. Then it creates a regular expression to find all the coordinates tags and capture the content between those tags. Next, it finds all the matches. Then it loops through all the matches it found. So for each match, he extracts the coordinate as a string from the match, and then it splits the coordinate strings into individual coordinates pair that are separated from a white space. Then he loops also in the pairs he found, and then he splits the coordinates pair into individual components that can be longitude, latitude, and a possibility altitude. So then he checks if at least a longitude and a latitude are provided. If so, he tries to parse the longitude and the latitude as a valueless double. Then, if both are valid numbers, it adds them on the list. The list is the path that we initialized before. Then, after he loops through all the matches, it returns the list of the points. Then we have also the load polylines methods that loads the polylines from the KML file to display the orbit path on the map. So first he called the method that I just explained, so parse KML from assets. So here we have the list of points of the path, and then it does add the points to the polylines. Polylines is a parameter of the class that is a set of polyline. Polyline is an internal class of Google Maps Flutter library. Then this set is provided to the map here as a parameter. So where we are creating the map, we pass the polylines of the orbit. That's how I've implemented the visualization on the tablet map, all the 3D orbits. Okay, so here we have the application. Let's start from the homepage, where we can find the two sections, one for Mars mission, one for Earth orbits. In the bottom we have a bottom bar with the settings page, where the user can insert all the necessary information needed to connect the application with the Liquid Galaxy. He can also insert a custom NASA API key. Let's connect the application with the Liquid Galaxy, and then we can go to the services page, where the user can clear the KMLs, reboot the Liquid Galaxy, show white logos, relaunch Liquid Galaxy, or shut down the Liquid Galaxy. We can also see and read some information about space visualization application, but now let's start from the Mars 2020 mission. Here we have a mission overview. We can read some text, but we can also meet the Ingenuity drone. Here we have a general description with some technical data. We have a 3D model on the left. We can interact with it. And we have the path of the drone in this synchronized map. Now let's meet the Perseverance rover. Also here we have a 3D model on the left. We have the path of the rover. We have some technical data about the rover, some text. But we can also orbit on this location by clicking on this button. By clicking again, the animation will stop. Then we can go to the Inspect Rover page. Let's waiting for the loading time. Okay, so here we have the 3D model of the rover. We can click on any component of it. For example, I click on the wheels. We can read the description for each component and learn about the structure and how the rover works. Now let's look at the rover cameras. Here we have a list of days. Those lists can be filtered in this section. Here the user can insert the parameters for the search. And here you can see the position of the rover cameras. And here you can update the list by fetching it from the NASA API. Let's click on a day. Here we have a list of photos taken by the rover on that day. We can see them. Now let's see the Earth section. Here we have a list of the most famous orbits. We have a general description on the left. We can click on one. For each orbit we can read some technical information. We can read also some information about one of its satellites. And here we have the 12 most famous orbits today.
Hello everyone, my name is Victor Sanchez and I'm a Google developer expert in web technologies. Also, one more year, I have the pleasure to be a mentor for the Google Summer of Code with our friends at the Liquid Galaxy Lab in Lleida. This year, I have had the pleasure of working with Mattia Baggini. Mattia has been working on the LG Space Visualization project, where we have kind of recompiled all the NASA Mars 2020 missions, with, of course, as well, some very well-known Earth orbits. Working with the LG is always an opportunity to take data and visualization into a more immersive, kind of impactful way. And Mattia has done an excellent job of taking some of the most wonderful NASA missions from that year, 2020, and showcase those missions in a new light thanks to the LG experience. Mattia, as a student, has been remarkable, I have to say. Probably one of the lowest touch students ever. He needed very little mentorship, so my merits this year have to be minimized even more than in previous years, because Mattia, from the very beginning, he took feedback extremely to heart. Obviously, we always start with much more intensive mentorship at the beginning, when we went through the documentation, through the code cleanness, to how to scale and prepare a project, not only to be a great project for the Google Summer of Code for this year, but for years to come, with good documentation, good structure, so other students can learn and take from them as year pass. Mattia took that at heart, and from week 2 and week 3, we saw a massive improvement on his way to kind of both code and prepare that code for the future. He has not only covered all the expectations from the project, but outdone even some of them. I think very meaningful as well is Mattia's willingness. He's going to give a conference about his documentation method and the different ways that he has done documentation for the project, that I think is going to be remarkably interesting. So not only he has shown technical abilities, but also those communication abilities that we so much appreciate in the engineering world and that we not always see in all students. Finally, another thing to mention is that the application is beautiful. As you know, not every Google Summer of Code application has that design aspect, and Mattia has kind of excelled in both the technical, the documentation, and the design aspects of it. We are extremely proud of the LG visualization project, and I think you are going to be as well when you take a look at it. So yeah, thank you, Mattia, for being a great student. Thank you, Andreu, for the opportunity of mentoring yet another year of Google Summer of Code. Hope to be here next year. Have a good one, everyone. Cheers.
Hello everyone, I'm Gerard Monsó from Agro, a village near Lleida, and today I will do the presentation for my project Wildfire tracked for Liquid Galaxy. The 3 main goals are represent live fires around the world, represent the historical wildfires for Catalonia, and represent the forest fire risk for United States. The technologies who use it in my project, there are so much, but basically Flutter it's the framework who used to develop the technologies who use it in my project. There are so much, but basically Flutter it's the framework who used to develop all of my project, and Dart is the language for this framework. And Another technology is VirtualBox to emulate all Ubuntu machines to run the Liquid Galaxy rig into these machines. And the IDE, it's another program who use it to develop this project. Another technology is you can see in this picture, but it's not important for another. In this library list, you can see all libraries who use it in my project. I would like to highlight any libraries like, for example, Dart SSH2. This library provides the service to connect with SSH to Liquid Galaxy to send all information or the image or all the interactions with the project with the Liquid Galaxy. Another one is HTTP. This provides the method to call the APIs. And the last one, for example, there are geocode. This library provides the translation, the latitude and longitude to a text address. Hello community. Now I will explain all of my source code and explaining all folders and all places with their functionalities. Okay, first in the lib folder we have any folders to contain any classes for different functionalities. First folder has entities. This folder contains all classes related to Liquid Galaxy. For example, line entity, lookup entity, orbit, with the objective to create any object to Liquid Galaxy for easy method and low code method. Only one instance of a class. We have created an orbit, for example, action. Okay. In the second folder we have screens. This folder contains all design of screens, like the list view, the collaborators screen, the maps right side screen, the settings screen. All screens it's contained in this folder. Next folder has services. This folder contains all classes who objective has connect to API, to external APIs and internal files who store more information. In this folder you can see GenCat, NASA and Precisely. There are the three main API who have my project. Okay. You can see LG service and LG setting service. This is the class who connect to Liquid Galaxy, make the action to sending information or do the connection or these things. Next folder has utils. This folder contains any classes who have actions, or for example the colors, the theme related things, the snack bar pop-up, or the skeleton of the body of my project. In the next folder we have widgets. There are any objects only for design and
cards or input icons. Okay, this is my main folder organization. And for example, if you see with more zoom NASA service, okay, this one, we have the first class, for example, define all satellites, the URL for this APA, and the default configuration. Okay, with NASA service we instance this NASA service settings and do the action to call to this URL and do the logic. Okay, if you can see in this code snippet, I do simply call to APA and the return CSR to with this CSB. I convert this output to a class. Basically, I return this function returns a list of countries. Okay, with the IPA output. If we can see the country object, basically it's a class to encapsulate all information of countries, and another code snippet get the satellite data Wildfire, and the same method of other function. Do a call to APA and the output. Do a call here to the APA and the output transform to an object. Okay, to a satellite data object and return this list of satellite data. Satellite data is basically all the information related to Wildfire, to any Wildfire. Okay, the NASA IPA returns all of this information, and after with this information I create an instances of these classes, and with functions like that or like that, I do the transformation to a Liquid Galaxy object, for example, and only calling with this function I will send a place mark entity directly to a Liquid Galaxy with the easy method. Hello, let's start to demo video. I will show my application running and all of its functionalities. Let's open the application. We will see all collaborators screen. The first screen has NASA Wildfire. This screen shows all fires currently in every country in the world. For example, let's put Spain and find Wildfires. You can see a list of current Wildfires with 4 hours of delay, and in the map you can see all locations of these fires. Okay, let's connect to Liquid Galaxy first. Perfect, you can see the successful connection. Let's return to to spine like fires. Okay, I will send this fire, for example. You can see the animation, all the information for this live fire. You can orbit with this fire. You can click and we will see the animation. Perfect. In the next screen, it's the historical wildfire in Catalonia. Okay, we will put this here and film historical forest fire. Perfect. The same in the last screen, you can see a map with all forest fires in 222. And for example, I will send Azure file. Perfect. You can see all the extension, and with red color you can see the all area has burned. You can orbit. Perfect. And the last screen is forest fire risk of United States. For example, I will fill any count on a street and film. This screen shows all information with fire risk, with any parameters, and you can send this in Liquid Galaxy with one click. In the right side, sorry, you can see the map and the location of this address, and in the Liquid Galaxy you can see the bubble with all information with wildfire risk, and a legend with green and red colors who can demonstrate the real risk in this area. For example, in this country, sorry, in this city has no fire risk because it's a city and don't have forest. For example, if I select a forest like that and send to Liquid Galaxy, we can see a special orange color because there are more risk of wildfire. Okay, you can read the same. And that's it, all functionalities of my application, and see you there. Bye.
Hi, I'm Gabriel, mentor of Gerard and his project Liquid Galaxy Wildfire Tracker. Just to say that it has been a pleasure to be his mentor. He came with a really good idea as a base of the project, and it was really easy to go forward. He was able to go forward in a kind of easy and motivated way. We struggled a bit with some issues with APIs, but at the end the result couldn't be better. Really happy with the result and with his performance, and nothing. Really happy to be here for another year, and as always be part of this family. And thanks again to Andreu to manage everything as he always does.
Hi everyone, my name is Siddharth Mudgil, and in this video I will give you an technical explanation of my GSoC 2024 project, that is GEMINI AI Touristic Tool. So let's get started. So first of all, I will give you the objective and scope of the project. So the main objective of my project was to provide user an AI-powered tourism assistant that can help user in finding tourist places, itinerary, or help in another aspect like can chat with the GEMINI AI and get some information. Then another objective was to integrate with Liquid Galaxy system to provide better visualization of the places. Then to provide user-friendly interfaces and multimodal inputs. So that was the objective and scope of the project. So the main technologies I used are Flutter and Dart, KML, Liquid Galaxy, and GEMINI. So Flutter is basically a open source closed platform development tool that by help of which we can develop Android application or web application and many more. Then KML is a markup language that is used by Liquid Galaxy or Google Earth, by which we can show different type of balloons or polygons, polylines on the map. Then GEMINI is a multimodal large language model developed by Google to provide like a response. So it is AI powered model. So this is the main graph of the project. So like when we open the app, so first we will see splash screen, and then we can see main screen. On main screen we can see sidebar and the first default screen that is selected, and that is tourist places. So main feature screen are like tourist place, budget plan, activity, recommendation, and itinerary. Then another screens are favorite screen, that is a screen user can like mark any place as favorite and store locally. Then chat screen, here user can chat directly with the GEMINI and get response. Then about screen will tell you a brief about the application and what is Liquid Galaxy. Then in settings screen is further divided into three. One is general setting, where we can like add GEMINI API key and other things. Then connection screen, here we can connect with the Liquid Galaxy. Then on LG control screen, we can control the Liquid Galaxy system by I provided main buttons like LG refresh, shutdown, show, hide KMLs, and etc. So let me give you a code walkthrough. So here, as you can see, this is my project, and in assets I have provided like normal images and other things. Then I have added different libraries like the Google Generative AI. It is for GEMINI. Then for caching or like local storage, I have used shared preferences and Floor. Then for dependency injection, get it. Then I am using block architecture because I find it more useful and more like structured. So I am using Flutter block. Then SS2 for SSH connection. So I have found some crashes. So I am using like local SS2 server. I have fixed in locally. Then Google Maps for showing maps and some others like this. For speech to text, I am using this speech to text package, then path provider and like this. So let me show you file structure. So I am using a clean architecture with MVVM and block architecture. So you can see in config I have defined routes for the application and themes. Here you can see this. I am generating themes, and in routes I am generating routes. Then in core I am providing core feature of application like all the constants, enums, custom exceptions, resources. Resources is basically a generic classes to store the app state like success, empty, loading. Then data state is for like network results. Then response handler is used to handle exception or like runtime crashes, so it will help in load. Then is use cases. I basically defined a generic use case so that all use case can implement or like extend this use case and have like consistent classes. Then in utils I have provided multiple utils that is used in overall the app, like prompt generator for generating prompts, preferences utils to store shared preferences, then map utils, just like that. So then the main are like data. So data is used to store or provide the data to the domain layer. So data I have like data sources. One is local and remote. Local is for like Floor database, which will store data locally, and remote is to fetch data from the GEMINI service or any API. Then mappers are used to convert or map data models to domain models. Then repository is basically used to call any data sources we need. Then in DI I am basically providing singleton objects to all the dependencies needed by any classes. Then in domain, same one model are used in all over the app is in model. Then repository, it is basically implementation, no interface, and we implemented in the data classes. Then in use cases I have provided all the use cases used in application like add favorite and other things. Then in services I have provided all the services used by our application like LG service for all the set, refresh, send KML, etc. Then location service for getting location from the address or name of the place. Then speech to text for converting speech to text or like text to speech, but I am currently not using text to speech, only speech to text. Then file service is to create a file. So basically currently I am creating file in cache only, not in local. Then in presentation layer I have divided all the feature wise. So let me show you one thing. All other are same only. So in Itinerary it is a feature, and for all feature there is block. One is event and another is block that will return the like current will emit the current state. So in panels and widgets are like component used by screen and similar panel. So I have also created one main thing that is used in all over the app. So block builder. So it will check for the current state like success and return the value needed like on success. I have passing a widget and it will return in on success. Then if it is in loading, it will return a data loading card, and similar to in error it will return no data card. So no data card and data loading card are common in all over apps, so it is consistent. So let me show you code. So for example, whenever we click continue button to get a response, so it will call an block event, and on event success we are saving that result to itinerary, and then we are syncing location. So the sync location function basically do is get let long from the location service class I have implemented. So this is location service class. So and then show balloon, move to place, and send camel. So that common things. So that was walkthrough. So thank you. That was all the technical explanation for the project. Thanks. So here is the demo of my application for GSoC 2024. So here is the Liquid Galaxy setup, and here I have opened my application in an emulator. So let me connect to the Liquid Galaxy. So as you can see, it is connected, and the Liquid Galaxy has moved to a default location. And here this sidebar can also like collapse and expand. So let me show you some feature of my application. So let's say we want to generate an itinerary, and I want to like visit Russia, and my budget is $2,000, and my duration is 4 to 7 days. So if I click on continue, it will generate itinerary of like multiple places to visit in Russia. So as you can see, here we can see the bubble also, and we can see a polylines of KML also. So here you can see, and if we click on like these places also, it will fly to that place by default. So like latitude and longitude can be somewhat off because it is emulator, so it cannot use location service. So then here is favorite screen, where we can store favorite tourist place locally. So here you can see, and we can also orbit around a place, as you can see. So it is orbiting, so let me stop orbit. And then here it is chat feature, where we can directly chat with the GEMINI API. So like I want to visit so if I click on send, so it will send. So like it also have like image inputs and like speech to text, but I cannot show in emulator because I do not have like tablet device. So here you can see it has generated some Himachal like destination like Himachal Pradesh, Uttarakhand, Sikkim, etc. So that was it. Thank you. So my overall GSoC 2024 experience was very good. I got to learn many new things and also face some challenges and also overcome those challenges. So I also applied for GSoC 2023. So I already knew what were my mistakes that I have not selected in GSoC 2023, and I solved that mistake and got selected for GSoC 2024. And I really like contributing to Liquid Galaxy because I like the project Liquid Galaxy itself, because we can visualize data on map. And for my project, I also integrated Liquid Galaxy, also have used GEMINI AI. So it was very interesting project because currently like AI is in very boom, so it is very interesting to work on. So the main challenge I faced during implementation was in SSH library by Flutter. So there are some crashes in that library. So with the help of my mentors, I resolved those crashes and implemented the whole project. And so and also like everything is implemented, and I really enjoyed working with Liquid Galaxy. And in future also, I will contribute to Liquid Galaxy and keep contributing. Thanks.
Hello, this is Vedant, mentor of Siddharth for GSoC 2024. My opinion is that Siddharth did pretty well for this GSoC, and I think he was very familiar with the Liquid Galaxy technology because he has worked with us for the past year, and he has developed a few applications like the Game Face one, and I really like that one. I mean, he won the Game Face contest, and he was familiar with Liquid Galaxy technology. He is good with Android. I would say he's very familiar with that too. I mean, talking about the code quality, it was really good. And when it comes to the visual appeal of the application, I think that is very good as well. And overall, the best thing about him is the damn smile, man, because the guy smiles wide and sometimes for no reason, and I think that's a good thing, a really good thing. And I'm pretty sure, like, if this is a Google Meet and he is in the Google Meet, I'm pretty sure he is smiling even right now as this video is being played. And I think that's a very, very good thing about him. And that smile is killer. And talking about my experience as a mentor, I have been glad that I got this opportunity by my mentor Andrew, and I've been working very hard for it. I am thankful for it, and luckily I was with good people around me. I mean, I had mentor Yash to ask for help. He was my mentor when I was a contributor, and now we help each other. I'm more like he helps me more than I help him. And I had mentor Prayag as well. He was the co-mentor for Siddharth, I'm sorry. And I think that has been very helpful for me. And mentor Prayag has been nothing but outstanding when it comes to him. And yes, I think this experience has been and what happens is sometimes you learn, even as a mentor, a lot of things from the contributors and the whole experience. And you realize that the responsibility of being a mentor is not just getting on the meetings and just guiding the person. It's a very huge responsibility. I mean, sometimes you have to get on phone calls, sometimes you have to sit with them and solve the bugs. Sometimes what happens is there is something urgent and you have to leave whatever you are doing and go and help the person. And sometimes you just have to stand at a distance and watch. And I think the decision making at that point is important, and you learn that while being a mentor. And I think I am very thankful for learning that. Thank you. I think that's it. Thanks.
Hello everyone, today I'm going to tell some of the technical aspects of my application LG AI Travel Itinerary Generator. So this is an application which lets you explore different parts of the world and visualize all the cities onto the Liquid Galaxy rigs. So what are some of the major app goals? The app goals is to let user explore different and various places on Earth using simple prompts. The second thing is to add your own destination or to where you want to explore. And one of the best features of Groq is to select different models. So here we are having different models listed onto the application. The next thing is to iterate through the place, so to giving more information about any place, and then let the user select the place he wants to explore. So if he wants to explore from the list, if you want to explore the second place, you can directly click on it and it will be shown onto the Liquid Galaxy along with a new screen where we are going to see the map and some of the description along with some of the information, where is that place, or the temperature, or the time zone, and some of the review. So now also giving users more control. They can easily control the switch between these places and from iterating through the list, and you can click any one of them and can explore any of the places. Speech to text to give more accessibility to the user. So these are some of the app goals. Now the next thing I want to tell you or to explain is how the application is working. What is the flow of the application? I am here and I want to explore, for example, Lleida. Then I will put a place name, for example, in this case, for example, in prompt I want Lleida, and then and I have done a pre-prompting where I take that place and then pass into my pre-prompt and generate a list of places using Groq API. So this prompt sent to the Groq API, and then it receives and we get a JSON response, and this JSON response comes up with a places or the list of the places with the relevant locations. Now the users can select any of the models, since Groq allows the users to select any models from the given one. So we have like GEMMA, GEMMA 2, etc. Once we get the response in JSON, we parse it. So after parsing, we are converting it to the Dart models. Next, after converting to the Dart models, we get specific, for example, the places, the locations, and the description, the name of the place. Next thing is how we are using the Google Places API to get the coordination, to get the coordinates of the places. For example, if I am searching for Lleida, then if I select, for example, Retiro Park, then it will going to give us the coordinates of that place. Next thing is, once we get the coordinates of the place, we then finally send it to the Open Weather API, which is an open source platform for getting the weather information. Once we get that, we are showing all the information like time zone and the which country it is in, etc., and the temperature. Next, these all things when after getting all the information, it is then displayed into the application, and also it is then converted to the KML and sent to the Liquid Galaxy rigs for more explanation and visualization of those places. So this is overall functioning of the application. Let's go through the technologies that I have used. So in this, I've used Dart or Flutter for building the application, the KML for showing the visualizations on the Liquid Galaxy, and Groq, which is the fastest AI inference for generating those responses. Now, some of the major libraries that I am using, although there are a lot of libraries that I'm using, but these are some of the major. So like Dart SSH2, which is used for sending the commands to the Liquid Galaxy rigs. Next is Google Maps Flutter for integrating the Google Maps. Then the Groq. Then we are having shared preferences for storing the data into the local storage. Next is DO for hitting the get request or the post request. Next is flutter.env. I'm using it for hiding all the specific API keys into my application. Next is speech to text. So as the name suggests, we are converting the speech to text for accessibility feed. So now let us go to the code and understand the API calls and a little of the functionalities to the API services. So this one is the Groq API service. So as you can see that we are having this get API key function. So since I want to hide the API keys, so I have put these API keys into my keys.env file, and then I want to get it from there. So I have written this function where we load the keys, and then finally we get the Groq API keys. Once we get the Groq API key, then we pass it to send post prompts. So this function help us retrieve all the information regarding a place. So once we write, for example, if we write in their Lleida to explore, then this goes into this function, and then it the user prompt that the user has sent and the model that we want to use. So it takes two parameters, and then these are like some of the authorizations in the headers and which is required. So here we getting the API key. So this is an async and await function, and this is the get API key function. So now it will return an API key, and then we are passing this API key here. Then in the data section, then we are passing the user prompt that what we want to get the response of. So these are the user prompt that I want to get the response of. Finally, I am putting the model and then getting the response. So if the response is successful, or if it is 200, then I am parsing it through the Groq response model. So I have created a Dart model which will help me parse all the information that I get from the Groq API. And if it is false, if it doesn't status, if it give any error, then it will be returning you a null. This is the Groq response model. You can see that this is the response model that I have made, and this is the response which I am getting from the servers. Next is get the available model. So this API call basically lists all the available AI models that are listed on the Groq. So as as I have shown you on there, that we can select different AI models, so GEMMA, GEMMA 2, etc. Next thing that you can see is the test prompts. So I have written like 6 to 7 different test prompts in order to test which one gives me the perfect. So the third one actually I'm using right now, and it is giving the accurate results and able to parse for all the models that are listed on Groq. So create an interlinked story of like 10 different stories about the place, and then provide the response in the structured data format, etc. So you can see this is the whole string, and this is the proper format that I want to receive the information, so that I can get a proper JSON response from the model. It is get travel destinations. So you can see that we are going to get a list of the destinations. So these are the send post prompt, and then we are sending. So in the post prompt we are required two things. The first one is user prompt, and the second one is the model. So whatever user puts the model, it will be passed. Once it will be passed, then we are going to get the response. So once we get the response, and then so after getting the response, it is not accurate although, so I need to like get everything within these braces. So it is important because sometimes it happens that Groq model gives response and writes something onto the first section, and then also at the end. So I want just the information between these two braces, which is for the JSON response. So once I get that, I convert it, and finally I write this to another model, which is travel destinations. So the travel destination basically contains the overall title of all the list of the places that we get. The next is the list of destinations that we get, and the list of destination contains name of the place, the description of the place, the address of the place, and the city of the place. In here we are trying to get the response, and this is the get response method. So here I am now assuming that it is not loaded in the beginning, so I'm just creating a check so that everything works fine. So once it is not empty, then we can say that the content is loaded and the loader will be removed. Finally, if everything works fine, then we push it and we go to the next page, which is a generated sub POI page. Once we get into this generated sub POI page, so as you can see that this section is the generated sub POI section. So once we get there, and we are having this generated sub POI section, and like these are the description, then I am mapping these entries and putting it into the list, just like this one, 1 2 3 etc. Similarly for the description also, and then once like anyone clicks on any of those, so let's say that if I click on these Qutub Minar, then it will going to get me through the another page, which is called the Google Map screen. So this is a Google Map screen where this screen is being shown. So this screen, this is the Google Map screen. So this is the get sub POI place info, where we are hitting the more accurate, because the responses that we are getting from the Groq model itself is not accurate, so we need to get the accurate things. So like the address. The next thing is how we're getting the images. So the images is being fetched from the places API itself. Once we get the photo reference through this, and then we use like maximum height and minimum height, and then the API key that to pass in, and then we get those string URL. So once we get, we then pass it to the body bytes, and then finally we convert it to base 64 and then show it onto the Liquid Galaxy array. Now this is my ssh.dart. You can see that I have different functions, for example. So this is the thing that we are going to get from the places API, and then we are converting that to base 64 so that we can display onto the KML. Next is this is the response balloon, where we are passing the information. So whatever we have, for example, what the data we are getting to show it in the Liquid Galaxy Rex. Then the coordinates we have, the place name and the text queries. Then once we have that, then we are going to get this balloon onto the right liquid galaxy rig. So that's all about this, some of the technical aspects of the application. Thank you so much for watching this. Hello everyone, my name is Rohit and I'm currently a Google Summer of Code intern at Liquid Galaxy. Today I'm going to demonstrate my application Liquid Galaxy AI Travel Itinerary Generator. So this is a simple application which allows you to visualize some cities of the world. Let me go through the application. So the first thing that you are viewing is the home page. So these are some of the predefined cities which you can directly go and explore. So we will do this later. So let's go to the side panel. Here we can see that we are having 3 different options. So Liquid Galaxy Management, Settings and About. So the About section contains all the information about this application, like who made this, what is the organization and all the logos. Next is we are having the Liquid Galaxy Management. So this is used for controlling the Liquid Galaxy rigs, whether we want to clean the slaves or to show the logo or to clean the KML, everything can be controlled via this buttons. The next thing is we're having the settings menu. So this is the settings menu where we can update the IP address, username, password to connect it to the Liquid Galaxy. Click on connect and it will get connected. So once it is getting connected, it will start to show this Liquid Galaxy rigs and the visualization. Here we are having the logo, we are having the camel. So let's again click on Agra and let's see what happens. So this time let's click on any of them. For example, if I want to explore the Agra Fort, click on Agra Fort and yes, so yeah, now we will be, as you can see that we are moving towards the Agra Fort, and you can see a little bit description about this. So the description, some of the reviews that the people gave here, so all of this is fetched from Google Places API. Okay, so let's see what this explore city does. Once I click on explore city, let's say Greece, I want to explore Greece, so let's click on explore, and once I click on that, I'm going to get again various sub POIs, you can see, and you can click on any of them and the same thing will be repeated and you will be redirected to the same places. And the best thing about Groq is you can select any models. So we are having a set of different models that Groq supports. So for example, if I switching to GEMMA 2, it will be showing the results according to GEMMA 2. And the generation speed depends upon the model speed and the network stability. So you can see that we are going to get these another sub POIs depending upon the model. Okay, so we are done with everything. One last thing is add on your own Groq API key. So because every API key has its limitations, so that if the default one is getting exhausted, you can add your own Groq API key and run this application. So that's all about the application. Thank you so much for watching it. So talking about some of the experiences in Google Summer of Code 2024, it is something which I can't just put through the words. So I remember I first heard of Google Summer of Code back in 2019 when I was in class 11th and was so much excited to apply for this. Finally in 2022 I just tried applying to Liquid Galaxy, but at that time I can't even set up the preliminary task and I was failed, and I feel so much demotivated at that point of time. But today when I see myself contributing a project in Liquid Galaxy, I'm feeling so proud, and it is something a dream or comes to a reality, and I just don't know how to express this feeling. The mentors and my peers is so great, and I don't know how this happens, but I do very silly mistakes, and mentor Andrew, always like a great teacher, helped me realize my mistakes and always teaches me the lessons to correct it. Thanks to all the mentors, especially for my project, mentor Yash and mentor Vedant. And it's like sometimes when I get the errors and the bugs in my application, I used to get freaked out and getting a lot of confusion, but mentor Yash taught me to divide the problem into the small chunks, and that helped me a lot, and at the end when you combine all the chunks you get the solution. So these are some of the little things that matters a lot. So I don't know like how to thank all of these, but at the end it's something great, and I definitely gonna miss this all. So thank you so much, Liquid Galaxy.
I have been a Google Summer of Code 2022 contributor back when I joined the Liquid Galaxy project, contributing to the La Palma volcano tracker. And in 2023 and 24, I have been the mentor. And this year, I've got the chance to mentor Rohit. And in this video, I just want to thank him for the wonderful work that he has shown us, the beautiful visualizations that he has shown onto the Liquid Galaxy. And I really like the approach that he has. Whenever you ask him about a problem, you give him the steps or the algorithm, he will be able to execute it well. He is very receptive to these feedbacks, and I really like his performance overall as well. And in this Google Summer of Code, I am just really overwhelmed that all the projects and all the contributors, how excellently they have performed. And it is just that now it is about to end. Then I just want all of the contributors to be successful and be able to get a very good Google Summer of Code experience. Thank you.
Hi, this is Shiveen and I am a part of GSoC 2024 with the organization Liquid Galaxy. My project with this organization is LG Fictional Travel Itinerary Generator, GEMINI. So what my project does is it will tell you the story of a traveler. That is, it will give you a point of view of what a traveler did there and what are the places that he saw. So basically, what the app will do is it will ask a POI, that is a point of interest, that is the place you want to visit from you, and it will generate a list of sub POIs, that is places within that place, let's say Qutub Minar within Delhi, that the traveler might visit. All of this is gonna get done using the GEMINI LLM model, and all of this is going to be connected with the LG. So basically you will be able to visualize the places that the traveler have visited, read its stories, and look at all those places, orbit those places using Liquid Galaxy. So what makes my application or my project different from other projects? That is the personality personalization. So basically, the traveler, the fictional traveler that you guys are going to see through, you can give a persona to him. You can give him a personality. Let's say you are an introvert and you don't like to go to crowded places, and let's say you want to go to historical places, and let's say you are a foodie and you want to go to restaurants as well. So what my application will do, it will create a persona for the traveler according to your suggestions, and that persona would affect the places that are being generated through the GEMINI, and you will get a result that would cater to your personality and your personality only.
Now let's have a look at these three classes. Right, now the settings controller, in here we have defined some variables such as LG IP, LG port, LG username, password, and RIX number to connect to the LG, and these parameters also have their own functions through which we can update them, such as update LG IP, update LG port, and all of these have the shared preferences in them. That means they will be saved even after you close the application. Okay, these are all different functions for that. Now let's go to the SSH controller. Right, this controller is when we are connecting to the Liquid Galaxy via SSH. Okay, we have some variables here: host, username, password, and port. Okay, client and connection. So basically, this connection is for whether the client has been connected or not, and this is used for some other things, such as sending the KML or things like that. Okay, we have a couple of functions here, such as connect, authenticate, ping, run command. We would be sending the commands to the Liquid Galaxy using this. Okay, we have query, we have close. That's all right. Now coming back, let's have a look at the home screen. Okay, so here we go. Now in the home screen, the entire content is divided into two parts. I will be explaining that in a bit. Okay, now this one and this one, these two are being used here for getting the user icon for the user. Okay, user icon is divided from 1 to 10, so I'm going to get that via GED preferences. And as API said, this is going to be getting from the SS controller class. Okay, and this is basically a semaphore, whether the LG is connected or not. Okay, and as I'm also adding a semaphore to get whether the API key of Gemini is set or not. Okay, so those three things are being called in this homepage. Now, homepage is divided into two parts, left and right. In the left part, we have the about page and some saved pages which the user can look into without making a Gemini API call. Alright, so all of that is within a single child scroll view so that you can scroll among them. Right, here we go. And then we have this side. Okay, now this side has a lot of things. So in brief, this has icons where the user can navigate to the next screens, such as voice screen. Okay, through which the user can say something, and I'll be explaining that in a bit. And apart from that, it has some other saved pages, such as beach page, some mountain page, and things like that. Okay, so let's move on to the next important page. Right, so we are gonna go, before moving on to those pages, let me explain a couple of things. Right, now let's start with saved responses. So, okay, I already explained this before. Right, these are some constant values. Now, LG controller, this has some functions, so that all these functions will be used in the LG settings page, so that you can just click on them and have those things appear, such as relaunching the LG, rebooting it, shutting it down, showing and hiding logos, things like that. Okay, settings controller, I will show you that. Now, this is for used for some API call I've done in the application. Now, here is a itinerary model. Okay, so this is how it looks. It has places, it has device itinerary, it has estimated cost, and a couple more things. Okay, so what that places class has are all these values and things like that. Okay, now this is exactly where the API call for Gemini happens. Okay, let me show you the function. So here we go. This is fetch item here function. I'm getting some things from user, right? That is, what we are going to do here is create a persona for the traveler, right? So that the traveler has a personality, and this is going to be defined by the user. And through this prompt, I'm getting all those things that I just explained. Right, so I'm using JSON decode, and sometimes we get JSON, these strings added into the response. So I'm eliminating them by this method. Okay, so this is where I'm creating the item, that is the object of the class that I showed you just now. Right, apart from that, in this particular function, I'm fetching the longitude and latitude of all the places that the AI has generated, so that it is mostly correct. Okay, and there's some other options as well. Alright, after checking it a couple of times, we are moving on to the next thing. Right, so let's see what else is left. We have some helpers. GEMMA helpers, these are basically some functions that have some values that are going to get replaced whenever I call them. This is basically used whenever I show logos. Right, this is for showing the images. And this is for screen overlay with story. This is store. And this is to go at places. Right, and these are all those functions that I'm using to send KML to the Liquid Galaxy. The next screen that we have is voice screen. So in this page, I am getting the voice from the user. You can also input the text so that we have a query such as Delhi. Right, the user can search and go on to the next page. And let's have a look at the final screen. Okay, now let's explain a couple of things about final screen. This is where I'm getting the data. Okay, this is for is loaded, so that user sees that loading option or not. Alright, this is the story of the traveler that I explained. I'm gonna show you the POV of a traveler. So whatever the traveler did there, that would be in this variable, and you would be able to see that on the left side of the screen, just below the map. Okay, now in initiate, I'm calling this function, and this function is basically responsible for doing the API call and setting the data in the final page. Okay, so apart from this, I'm using this function as well. This function is used to fetch the images from the API. Right, here we go. Now fetch places. So basically, this is where I'm using the access token or the API key for Pixabay. Right, the place where I'm calling the images. And since images are no longer valid after 24 hours, I'm doing this both for the saved pages and the unsaved pages. Right, and we have some couple of options such as fly to. Right, using this, the user would basically go to that place. Right, using KML. Okay, and this is basically it. Right, and I will also be showing the image of that place along with the story of what the traveler did there on the LG screen. Apart from this, we have orbit button. Right, I've also added a way to stop it. That is, I will give an array of bool elements whether the orbit is done or not. Alright, So apart from this, we have one more function, that is touring. So basically you will go to all those places one by one, and you don't have to do that manually. On the app itself, it would be changing the story and the map, and on the Liquid Galaxy, it would be going to that place and would be showing the story on the rightmost strip. Okay, let's have a quick look at all the other pages. Right, this is the about page. We are showing all the logos of all the organizations here. Right, then we have the LG homepage. In here, I'm showing all the options of what the user can do with the LG, such as show logos, hide logos, reboot, and things like that. Okay, we have all those functions designed in the LG helper that I showed you before. Right, this is some of the saved pages. I'm letting the user see 4 places, such as Rio de Janeiro and California, that have some prominent beaches in them. Right, we have settings page, and we have 2 pages. This is the page where I'm letting the user enter all the information, such as the API key of the Gemini, the LG information, and things like that. Now this page is where I'm letting users set all the persona of the traveler. Okay, and also having the user select the user icon which he wants to use for the application. I've already showed this in the splash screen, and this is the warning page basically. Okay, and it has whether to go to the next screen or go to the back screen. One thing is left, the maps. Okay, so the maps is synchronized with the Liquid Galaxy simultaneously, right? And I'm using a variable to stop that for a couple of seconds so that it doesn't affect with going to that place and the synchronization. Okay, now this function right here is used to convert the zoom of the map, Flutter map, to the zoom of the Liquid Galaxy application, right? And this page right here, I'm also letting the user see all the locations that the user can visit on one single page. And this is also synchronized with the Liquid Galaxy, but it is mainly for the application user, so that he can also have a full experience even without having the Liquid Galaxy itself. So that's it, I suppose. Then let's start with the application demo. These are all the logos of the company that we are affiliated with. This is the home page. Here we have 2 semaphores. One is whether it is connected to the Liquid Galaxy or not. The other is whether I have entered the Gemini API key or not. We have some places already saved for the user, so they don't have to do an API call to the Gemini. Apart from that, we have search option, beach and desert option. In the beach option, I have saved some places that are famous for their beaches. Now let's look at the About Us page. In this page, we have logos of all the places that we are associated with. This is also on the splash screen. Now let's come back. And now let's go to the settings page. Okay. And in the settings page, we have all the information saved. You can just enter that once and save that. Now let's connect to the Liquid Galaxy. Right. And as we connect to the Liquid Galaxy, the logo is already sent to it, and here are all the functions that are associated with it. Right. Now let's test one of the options, that is clear KML. Right, and that's cleared. Right, now let's go back to the home screen. Right, and after going back to the home screen, let's go search for some place. Let's say that place should be Delhi. Right, and next is the final screen. We have to wait for a couple of seconds here. Now let's go to some place such as Humayun's Tomb. Right, in the left side, the map is changing wherever the position of Humayun's Tomb is, and in the Liquid Galaxy, you are on the Humayun's Tomb as well. Now there we have some picture of the Humayun's Tomb along with the story of the traveler that has traveled there. These are designed for the bigger screens. That's why it's looking big in my virtual setup. Now let's have an orbit around Humayun's Tomb. As you can see, the orbit is happening, right? And we're coming on to the main page. Now let's have a look at a tour. So what the tour would do is it would go to all those places one by one in both the Liquid Galaxy and the map area as well. Now that is for the mobile app users specifically, so that they can have a look at all the places that are there at once. Now let's come back to the home page. This is the personality page. You can also change the icons here and define a persona for the traveler that you are sending somewhere, so that you can get your itinerary accordingly and the story accordingly as well. So here we go, this icon has changed. Now let's have a look at some LG controlling options. Okay, since we are done with the demo, let's shut the device down. Now, here we go. All 3 of the devices are now shutting down.
So this is about my GSoC experience. Right. So getting selected for GSoC was not something I expected. But since this is something that happened, I was very happy about it and it was a wonderful experience. So, the organization that I was selected for is Liquid Galaxy, and this organization works in parallel with Google Earth, and that is a very interesting thing. It displays Google Earth on multiple screens, and that is a very good thing for visualization. In this organization, I met with many contributors, my mentors, and many other mentors, and our project admin, Andrew. Getting in contact with the contributors was a wonderful experience. We worked together, we asked each other questions, helped each other, and that was a very good thing, like talking to other people who lived across the world and communicating with them. That is a good experience. My mentors, that is mentor Vedant and mentor Prayag, they helped me along the way through the project. Now, my project was an interesting thing in itself, and making it was quite fun. The challenges, well, the challenges that I faced were mostly personal. I had my exams and semester exams during this period. I had typhoid fever during this period, and I also met with an unfortunate car accident that happened during this period. But despite all that, I'm very happy that I have completed this project and doing the final submission. Getting selected in GSoC was a wonderful experience. It was a learning experience. I learned a lot of things. I met with a lot of people. I communicated with a lot of people. And I had a glimpse at how an organization works, how an organization does things. It records everything. It asks you for everything. And there were many other techniques that I learned that would be helpful for my future ventures. And I'm thankful for GSoC for it.
Hello, this is Vedant, mentor of Shivane for GSoC 2024. And talking about my experience with him, Shivane has been nothing but a good pupil. And during the coding period, he had to face some health issues, but he fought back and completed his application within the deadline. And I am proud of him for that. And apart from that, I think that he's a very creative person because he implemented some features in the application which weren't in the original project idea, but the first time I saw them was in his project proposal. So I think he has been a very creative pupil and a hardworking one as well. And he persists actually. He has good perseverance. He just gets things done by hook or by crook. And apart from that, talking about my experience as a mentor, this was my first year as a mentor, and mentor Yash was my mentor when I was a contributor, and it's really a good thing because now I can learn from him while being beside him as a mentor. So a lot of time mentor Yash helped me a lot, and apart from that, mentor Prayag also was a co-mentor for Shivane, and he helped me a lot with that with him as well. So yes, I think it was a very good experience. Thank you.
Hello everyone, my name is Dalvi. I am a contributor here at the Liquid Galaxy organization for Google Summer of Code 2024. I am creating a project known as the LG AI Touristic Explorer, which is a Flutter application powered by GEMINI API. So my application generally delves into the idea of exploring cities. So suppose you want to get to know about a city, you can explore three of its main aspects, them being the geography of the city, the historical elements to it, and the culture which it participates in. So these three important are the main structures which my application surrounds around. So we get the information about each of these in flashcards for the user. Also, the fourth most important thing which a tourist looks for in a city is the places of attraction or points of interest. So I also provide a list of POIs which the user can cycle through and visit in the Liquid Galaxy rig through visualizations and orbits, so the user can have a better idea about the city. Also, last and not the least, we have the narration aspect to it, which is I create a story out of these different facts which I am gathering, and this story is then narrated using a narrator, gives an immersive experience to the user, and he gets to know about the city in a audio format. So that was a brief description about my project. Now let's move on to the technical description of the code of my application, and then we can move on to the demo. So yes, let's start with the technical description of my application. So the application is built using the GEMINI API. So I can show you the GEMINI API service here. So GEMINI API service has the different prompts which we use. So this is a remove markdown function which I have used to remove the unnecessary markdown code which is generated in the response. Then moving on in the generate story function, you can see we have a prompt inserted there, and it returns the response that is the story. Then we have a generate city description tag to generate the description of a city, and then we have finally a generate facts option. Here I have also added the response as a part of the prompt to get a better response in a JSON format. Then it is the response is cleaned, the markdown is removed, and then finally, after everything, we send the historical, cultural, and geographical facts, and then we get a from JSON function in the city model class to get the city class as a response. So this was for the GEMINI for getting information about the city, and in the orbit connection class you can see there is a similar one for generating the POIs. So we have a prompt here, then we have a function here to get the coordinates. This is using the geocoding library. The geocoding package then generates the latitude and longitude. Then we have a Google Maps API, Places API to get the images for each and every point of interest. So this was for the GEMINI aspect of the application. Then we can move on to the multilingual support. So for multilingual support, I have supported almost 7 languages and 7 to 8 languages, and for that I have also added the different JSON files, which you can see here. These are the different JSON files for English, Spanish, French, Hindi, etc. So when you toggle it in the window of that, you can see I have ordered the fallback is English, and all the data regarding the past used language is stored using the shared preferences package. So you set the selected local currently to the one which was saved earlier. So yes, this was for localization. Then for themes, there is a theme changer package, which you can see has it is wrapped with change notifier. So it uses provider to set the theme, toggle the theme between the 4 to 5 different between the different 6 profiles, and the profiles are mentioned in the constants. So yes, these are the constants which have the different profiles, the language codes, etc. Now let's move on to the main application, like the home screen. Tutorial have different targets which are added. So this is about the about key. This is for the language key. So these are about the different onboarding carousel, which you can say, which is portrayed in the home screen. The next thing what we have is searching for cities. So Google Play's autocomplete text field is used to get the search for the cities in the application. So here we have a function here that is on item click. So on item click you get a prediction. So to differentiate between all the different results and cities, there are different types of predictions. So these are some types which can be accepted for cities, and then if it is a city, then only you are given a positive response and you can do it. Then you are moved to the city information screen, where if the city is present by itself, I have also added some pre-prompts. So the pre-prompts are present here. These are some pre-prompts which are present, like the place images and some of the cities which have some city outlines and historical maps with the given descriptions. Also the place of POIs, like here you can see these are the POIs of Austin, which are already stored in the algorithm for easy access. So yes, that was about the already stored pre-prompts. So now when we move on to the city information screen, one of the functions which you can see is the use of DeepGram API. So the DeepGram API is used for text to voice, and you can see the API is hit with the content which is generated, and it is stored in the application directory and written as bytes. So and then you can play and pause as much as you like. So yes, that's about the story narration. Then we have the download widget. So the download widget, what it does is it sends data to the liquid. It sends KML file to the Liquid Galaxy rig by downloading it from Google Drive. So I have already initialized the links of the Google Drive, and for each historical or outline type fact, the information is the KML file is downloaded into the applications directory and then sent to the Liquid Galaxy rig and visualized. So yes, so this is the code for downloading the KML file. You get the download task with the URL, that is the drive KML, drive URL that's saved, and these are the general requirements. So here you can download the file. This was it for the technical description of my application. Now the following video will continue with the demo. So moving on to the demo of my application. So this is my Twitter app. First you are greeted with this splash screen, and then you are taken to this page. So this gives a warning about the hallucinations which occur during the generation of data. So when you click on understand, then you are greeted with onboarding flow. So you can see it gives us the directions, and it shows us the different components in the home screen. So the drawer, so the different sections here, and I have also started my Liquid Galaxy rig running in the background, so it is already connected there. So here you have to, I will just show you all the components. So this is the home screen. You have the different cities which are recommended here. Then you have a search bar where you can search for the cities. Then you have the drawer having the different options here. First, the Liquid Galaxy tasks where you can see different tasks. Then we have the connection manager where you can add all the details of the LG rig and also set the API keys. So let me just set the API keys. So yes, I have already entered the data of the API keys. Now if you click on this button, you will be able to see the data, but I will not show it to you now. And when I click on save, the data will be saved and you can go back to the home screen. Here you can see there is the connection manager which we just went through. Also the language selected. So here we have a drop down having the different languages which are present in this application. So for example, if you click on Spanish, you can see all the data here has been turned into Spanish. Italian, you can also have Japanese, Chinese. You have all the different. Currently I will continue with English. Also there is an option to choose the theme for this application. So you can have a greenish theme, you can have a dark purple, you can have a teal or a greyish theme. You can go with the purple theme for now. You can go to the about section, which includes the detail flashcard, details about me. So now we can move on to searching for actual cities. So we can choose one of the cities from the given outline. So like you can see Barcelona, Spain. What happens is you get the map updated here and a KML file is shown here giving this image of the city along with its description, and the points of interest are marked here as well. And in the application you can see there are different flashcards which are available like the history, geography and culture, which have different facts about the city. Also you have different points of interest like the Gothic quarter, etc. And when you click on a certain topic, you can see there are 4 different buttons here. First to show energy, then you can have to clean the balloon, you can start the orbit around the particular point of interest and also stop the orbit around it. Now when you click on start orbit, what happens is the information is sent. So as you can see, the flashcard is visible here as well with the information of the city and the image, and it is moving around this point of place of attraction along with the flashcard which is visible in the app itself. And when it moves to the next one, you can see the app also changes its flashcard. So it is showing this spark here. It is giving its information as well. So what you can do, you can also stop the orbit here. And now what you can do here is you can narrate a story about it. So you can click on this button here. What this will do is this will send a prompt to the GEMINI API, get a response, and then hopefully you are able to hear it. So you can start and stop it whenever you want. So this is the narration aspect of the application where you can narrate any story here. Now we move on to the extra visualization. So what are extra visualizations exactly? So what they do is, so for this city we have outline. When you click on outline, the data will be downloaded in the application directory, KML file, and then it will be sent to the LG rig. And now as you can see, the information has come here about Barcelona, and when I move the rig on the map, I can see the total outline of the city. So what are the components, what is the different districts, you can see everything along with the maps. So this is the extra visualizations component. Now let's go back. You can also search for any given city at a given period of time. So let's say you go for Singapore. When you search for Singapore, the LG map first goes to Singapore, and then you can see the image of Singapore along with the flashcard, the description, and this flashcard is being generated. So when the flashcard is generated, you get a positive response. You can see it has generated the historical facts here, along with the geographical facts and the cultural facts. So you can see the points of interest have also been generated. You can also visit them one by one. So this is all generated using the GEMINI API, and when I click on start orbit, you can see it has started orbiting around the different POIs. You can see the different photos as well. There is also an option to stop the orbit. Yes, and if I go back to the home section, and if I, let's say, change the language to Spanish, and I search for a different city, let's say Madrid, you will see we'll move back to Madrid, we'll get a photo of Madrid as well. And it is generating its data. Now you can see the interesting fact here is the data which is generated here is in Spanish. You can see it here, everything is in Spanish. Geographical data, cultural data, everything is in Spanish. Even the points of interest which are generated are in Spanish. So we're gonna go back and let's say we go for a city, let's say Mumbai. So now you'll be transported back to Mumbai. And here we can, when you look at this extra information, you can see there is a different visual, which is historical fact. When you click on this historical fact, it is downloaded. Now you can look at it. Take some time. Yes. So now as you can see, the information is visible on the rig. It is showing the historical map of Mumbai with its 7 different islands and how it was supposed to be earlier, before everything. Yes. So you can see all the different islands before it was one entire landmass. Yes. That was the majority of my functions of my application. Hopefully you liked it. Thank you.
Hello everyone, my name is Alfredo Bautista, and in this video I want to share with you my experience as a mentor in the Google Summer of Code 2024, in my case in the Liquid Galaxy project. This experience was amazing. This experience gave me the opportunity to connect with other enthusiastic people around the world in the technology. In my case with Manoj, he is from India, he is a student, and we connect to build a very good product around Flutter and, this year around AI. So the experience was very good because you can connect with other people and you will improve your skills, your soft skills, teaching like the technology that you know to other person that he is starting in this technology. So in every week we learn a little bit more about the framework, we learn how to integrate the AI successfully in the app, and we face some problems but we solve at the end. So in general, I recommend to everyone this experience because you will grow as a person, you will grow like a tech or like a tech person because you will get more soft skills to share your knowledge with other people. That is very, very important. And also for the students, he or she has the opportunity to connect with other experts or other people in this technology. So I think it's a very, very good experience. So in our case, we build an AI product around the Liquid Galaxy. For me, it's a very, very good product because you will connect with an AI agent that this agent will show you like the map and will show you some dates or some relevant information about the city. So I think it's a very, very good product. So yeah, at the end I want to say thank you to Andreu for the hard work connecting these people and also managing the Liquid Galaxy project. Also I want to say thank you to Manas because we learned a lot about some problems in Flutter and how to solve in the months that we work together. Also, we shared a lot of experience in this summer. So yeah, at the end I want to say thank you to all people involved in the Liquid Galaxy project and also in the Google Summer of Code. So see you around. I hope that you enjoyed it as me, this experience, and also I want to see you in the next edition in 2025. So thank you so much for your time and see you. Bye.
Hello, I am David, and today I will be talking again about my project LG Agro Task Manager. So Agro Task Manager, as we've established before, tries to fix the problem and automate the work in a crop field using robots. So there's this robot that I've been based on for the whole time, like I've been using it as a reference, which is the Amiga robot. Now, what we will do with this app is that we will send it a queue of tasks remaining to do or tasks that you want it to do in a specific field that you have set the robot to work in. Then the thing is that you will have a queue of tasks, so the robot won't need to have you selecting tasks constantly. You just set the queue and it will do it by itself. And now, even if originally I started working with the Amiga robot and consulting the API and everything, sadly for the reviews and stuff, we will be seeing just how we do it with hard-coded information instead of the actual API or the Amiga robot, because we've lost access to the robot and it's much easier for the presentation. Now, there also is a feature in this app, which is a database where you store the crops that you use. Then you select which fortnights it's planted on. So for example, if it's from January to, you can plant it from January to February. You select from the first fortnight to the fourth fortnight, and you do it like this for the transplanting dates too and the harvesting dates too. So then when you're in the main menu, you will see a table which includes what plants have some kind of task in season. So when you're in the main menu, it says, hey, it's harvesting time for pumpkins, for example, right? So where does LG come into all of this? So there's two main things, or actually, well, yeah, two main things, which is the visualization of tasks and the visualization of the notifications, as in what tasks should I do based on the season that we are in. So in the main menu, there is a bit of a button. If you click it, it will display right here the plants that are in season, and we can also visualize the task that the robot is doing. It will bring us, the KML will bring us to the field, and it will say which robot is it, what field we are in, and what the robot is doing, and we'll have a delimited field there. So then, for a bit of a technical explanation, right? We haven't used any AI on this project, but we've done loads of focus on software engineering techniques and object-oriented programming. So we have a very complex, quite complex logic, right? For the tasks, the robots, the crops, and everything that relates one thing to another. And we manage all the tasks with a class called Task Manager, which somehow connects the robots and the class and the task class and the views and everything. So it brings us together. We've done from the midterm from now, we've done a great change with my mentor in this department, because the logic was very faulty back then, and now it's got a very strong backbone and very solid principles of object-oriented programming. And last but not least, we have done a very organized project when it comes to how the classes work in Dart, because before beginning this project I wasn't aware of what a view was, what a view model was. I didn't know anything, and thanks to mainly my mentor, which is an expert in Flutter and Dart, I've been able to create a very organized and functional now application. So now we will be doing a little bit of a demo. So first of all, we have here the main screen. In the main screen, we have this table with all of the plants that have some kind of task that has to be done to them now. So for example, spinaches have to be planted, and we get this from our crops database. So if we come here, we can add a crop with its first fortnight of planting and last fortnight of planting, right? And it goes the same way for transplanting and harvesting. So if we come here to, for example, eggplants, we can see a table which indicates the fortnights for every single task, and the orange one means that it is coinciding. So we're in that fortnight and that task has to be done. So it will appear on the database. So if we connect here to the Liquid Galaxy, we will see that the logos appear right up there. And then if we come here, we can visualize plants in season, and that will create a KML where we can see all the plants that have to do something. So for example, pumpkin, eggplants and tomatoes have to be harvested right now in this fortnight. So the next thing that we have to do is come here to robots. We have 3 robots right now. Each of them, see, this one is simulating a task still from before. So what we can do to John here is we can add him a couple of another task while this one is simulating, and then we come here to visualize. Now what this will do is that first of all, here on the tablet screen we will be seeing Google Maps with a little pinpoint to where the field is, and here we are traveling all the way to India to where we have this delimited field, and right there we can see that we have a KML displaying the robot's name, what it is doing, and where it's doing it. So it's in Karur, India, and every single robot has a different field attached. For example, here we have Hortensia, right? And Hortensia is working all the way in Southern Europe, in Saros. So we will see now that the Liquid Galaxy will be going all the way to the Iberian Peninsula. Yeah, and see, we can see that Hortensia is doing watering in field 1 in Saros, and we have the delimited field here. And last, I'll show you how to add a new robot. Right? We can come here, select its name, its IP, and serial number, and here we have a list of all of the fields that we have. So, for example, if I create this one, which is in Rajaoya, and call them hi with whatever IP. Oh, damn. 1 and 1, right? And I gave this robot a task, which is planting, and we came to visualize. First of all, we will be seeing here again in Google Maps the point, and then we'll be going all the way again to Rajaoya in India, along with the KML saying that the robot hi is planting in Rajaoya, the number 2 field that we have, and there is the KML. Okay, so in order to finish this video, I'll be talking a little bit about my experience in GSoC 2024 and what's been good about it and what's been bad about it, but it's mostly good, don't worry. So the first thing that happened was a mistake on my part, which is that apparently I had to select that I had a big project, and I wasn't aware of that. I thought the big project was a very huge project, right? So I selected a medium project, so I got stuck with that. But yeah, that's a me issue. I can blame anyone but for that, and it is just a little anecdote, right? So then what else? One very good thing that we had here doing it at the Liquid Galaxy Lab is, first of all, being able to work with Andreu, and in my case my mentor Victor Carreras, which have helped me greatly. And Victor especially has helped me understand a lot of how Flutter works, how it should be divided, right, and how I should start a project and apply the concepts that I already knew from programming in general to this language, which can be a bit difficult and frustrating at times, but we've managed to do it in the end. And yeah, it's needed to say that you have to work a bit hard, and even when I was working, I was lagging behind in some things because I got distracted with things that weren't as important for the app, and I was just lagging behind and getting behind. So it's a bit difficult to keep up the pace, but when you finally finish the app, it's very rewarding. It's really satisfying, and I recommend it to everyone, but you have to be prepared to be working hard. And of course, as it always happens in programming, you will be getting a little bit frustrated when things aren't working the way you want them to, but that's just what we signed up for. And yeah, in general, I really like this experience, and I hope that I can keep working with Flutter because I've grown to really like the language over the past few months.
Hello everyone! My experience in the Google Summer of Code of this year makes me feel like Liquid Galaxy is more mature and reinvent itself with new challenges, new values, propositions, and new opportunities year by year. That is wonderful because I can expand my boundaries to new horizon as Flutter and Dart mentor. And on the other hand, my mentorship has been challenging, helping and achieve goals and accomplishments. This year has taken my skills to new level and is something that I have enjoyed a lot, and I have a great pride of it.
Hello, my name is Oscar. I'm doing the Android Chrome and AI application management project for the Liquid Galaxy community, and I'm going to show you my main work here in the labs. main part of my work has been uploading all of the GSoC apps and previous apps that the Liquid Galaxy community managed to create during the years of 2023 and 2024. And here I'm going to show you one of the apps that we made in the GSoC, and I'm going to show you the process to upload it to the Play Store. The most important part to do this is actually having the data for the Play Store, the AAV, the little screenshots and the icons. And what you need to do is come to the page for the app content, go part by part. For example, in the privacy policy, you need to put the URL for the privacy policy that you have for the app, and then you have to go, for example, in the app access, you need to put the information that you need to give to the testers so that they know what they need to do to test the app. For example, in this case, they need a Liquid Galaxy rig, but in this year GSoC we made it so it's optional because the apps are supposed to work on the tablet. And they also need the API key for the app to work, and this app uses NASA. Then on the next parts are basically filling up little tabs that you need to see. For example, the ads, you would say it uses or it doesn't use ads. In the content rating is a little questionnaire that you say you use this part, you don't have this part of content in your app, you don't have this content, or you have, and then it gives you a rating for the ages of the different categories. And for example, in Brazil, it's for all ages, and in most places it's for all ages except some that are like 3 or older, but that's really young. And it's important because you need to have this so the Play Store can distribute the apps to the correct people. Then you also add the target audience that you want. In this case, we added all the ages because it's an app for everyone to see. You also tell if it's a news app. The majority of these are no in our case because we don't really need to. Well, we are not a government, not financial, we are health, and we don't need to use any of these parts. So for example, in the data safety, it's really important to be transparent and clear with the data that we use, because the Play Store is really strict with this content. Then we have the advertising ID, that is basically you saying if you're using any ID with your packages, and in our case we are not using it. After this part, the next most important part is going to be the main store listing. That's the part that you see on the Play Store. And in our case, we put the app name. In this case, it is LG Space Visualization. We also do a little description that is at most 80 words long, and a full description that is 4,000 words long. Then we introduce the app icon and the feature graphic. These are made by the contributors that also make the apps, and then they also send us some screenshots from their apps to put in the Play Store. And then probably the most important part is the actual release of the app. We have in our case, the Play Store wants AAVs, app bundles, and we put them in here, we upload them, we write, like in your case we have this is the first production release, so we place that, and then we send to every country that we select here, and in our case we decided to put every country in the world, and they are sent on every region through the Play Store. And now I'm going to show you the actual Google Play page. This is how it looks. It's, as you can see, the screenshots are here. The icon for the app, the name, that's the data safety that we introduced in the other tabs, and the about for this app. Then from this we pass to the next part of my work, that is a lot of documentation. I had to really do a lot of documentation. Like we have, for example, here the document to the Liquid Galaxy installation. We have different parts, like the main part of the rig installation. Then we have the AI server that is going. I'm going to show you this later. And for example, in this document explains how to go about the installation step by step, from the main OS installation to even the little bug that we can find during the installation. In here we have some applications that use Node.js, and for example we have the LG Retro Gaming, that is an old app that we have here in the community. It uses the Node.js, and it shows the game of the asteroids, the little spaceship flying around the LG through the main screens and shooting to some asteroids. Or we have others, like the other retro gaming line, or even some other apps, like for example this year one app uses Node.js to show some images from a space robot. Then we have, for example, another manual that is used to install the screen that you can use to move the Liquid Galaxy through spaces, and use it in Perusa Rule. That is another program that we have. It's an old program, so it has a bit of problems. But using it, we can move the Liquid Galaxy using a touch screen. Then we have the manual that probably I touched the most, the Play Store manual. In this manual we have everything that is related to the Play Store, mainly what do you need to do to upload the application, what the other contributors need to send me, in this case for the Play Store to have all the screenshots and all the images necessary. Also we have here a bit of like explanation of what the Play Store is, and the Play Store console is, and the store policies. And we also have, for example, in this case it's a new addition. I put the way to have from an AAV to an APK for us to be able to test it easily using the Android tool bundle. And in this case, in this document, we have what the contributors need to send me to actually be able to have the app on the Play Store. And it's really simple. What they need is the app bundle, the JS file, that is a key that they use in the app bundle to be able to identify the app bundle. Then the text, what I told you before. Also the graphics that are the icon, a big image to make it like a banner. Some screenshots, and this is optional, but if they want to send a small video, they can. And then there's also extra part, like saying that Google is really strict with all of the data and everything in the packages, so they have to be correct, and other things like some policies here for the Play Store, so they can be more clear when trying to do the other contents. And in here is the next part of my work, the Liquid Galaxy AI server. In this document is the setup, what do you need to do to install the server and run it with other apps using Docker. And we have also the specs. In this case it's using Groq Linux and using in this one the 970 RTX. And the server uses Docker, or in our case it uses Podman to emulate Docker. And the main part about this server is so that we can test AI apps using our server, so that we have the Docker, so that we don't break anything inside the server. And what we do is mainly install the Groq Linux. First we have a USB, we plug it in on an PC, and using Rufus we board the OS into the USB. Then we pass it to the server, we install everything the correct way. Here is what it says to do using the correct space for the disk and everything. And then from here we can see the installation part, that is to prepare the actual PC for the Docker installation, and then we go to the Docker installation. And here we start installing the Docker. We use some commands to actually have the Docker ready for the work. And then we start with the networking part, that is really important, because if we don't have any access to network in our PC, we can connect to any tablet that we use, and we can use the AI server for the Liquid Galaxy. Then probably the most important part is testing if it works. And for this we use a lot of apps that were made in previous years during GSoC. And some apps are here. These are the old apps. This is the installation process for every app. The majority of them is just have the Docker ready, the image in Docker Hub, pull it from Docker Hub, and then run it in the server. In this case, we do the Docker pull. We download it here in the Nipple image, then we run the app in a port, and then we do the tests on the tablet. I'm going to show you later how we do the test and what apps we test here. And then we have the other apps, and in this case, this year at the end we didn't really have any major apps that use Docker. We only have one project that uses it. So in the end, this year Docker was a bit interesting. But in our case, we did really change really late. So we also had to do a lot of tests and work with this year's contributors for the Docker. The main parts were really the connection and the making sure the AI is working, and for the rest it's mostly easy to make the tablets and the info. And also there was some issue with how the AI handles the information, but that's something that was so easy to work around. And for this, some of my main work. Now I'm going to show you how we test things here in the labs, and I'm going to show you an old app that we have. In our case, it's going to be an AI app, because this year we really did a lot of testing with AI. And I'm going to show you first the demo of the app, and later I'm going to go through the process of testing them, telling what do we check for and what do we need to be careful for the app to be correct, working, and I'm ready for the Play Store. Okay, now I'm going to show you the Play Store part. As we can see, we have a lot of apps in the Play Store. There are some that I personally uploaded, like for example the Super Liquid Galaxy controller, or the GEMINI AI Touristic Tool, or in our case, this one, the Animal Discovery AI. And I'm going to show you a demo of the app, and later I'm going to show you what we check for the testing. Choose the app loads. Then, as you can see, in the LG connection, it's red. That means we need to connect the app. So we go here to connect to the manager, and every app has these parts: the username, the password, because if they don't have this, they don't know what to use for the commands. And then we have the master IP address. That's really important because this connects to the main screen on the Liquid Galaxy. Then that sends the information to the others. Then, after inputting the information, the next part is the port number. This is the port that uses for the SSH connection to be able to interact with the screens. And then the number of LG screens. In our case, is the 5-screen LG rig. We connect. It takes a bit too long, and then it will say that the connection is correct. Or I can mess it up and it's incorrect. Okay, now I'm going to show you the Play Store, the list of the apps that we have. In the Play Store, I already deployed some of the apps, like the LG Space Visualization that I showed before, or this one, the Super Liquid Galaxy Controller. And I'm going to show you now the process that we do for the demo, and then the process that we do for the testing. First, we open the app. As you can see, the app has all the logos of this year, and it's already connected with the API and the LG. That's because we made so that the connection is instantaneous, and it also saves the information of your Liquid Galaxy in here. This app is for the controlling the Liquid Galaxy, having the clear KML that we use a lot in the here in really easy access. And some things that we do on this app is, for example, we have the Earth. We can go here to the moon. The Liquid Galaxy loads and it goes to the moon. We can also go to Mars. We do the process and we go to Mars, and we go back to Earth. Some usability of this app is, for example, we load some points of interest. In our case, we're going to India, West Bengal. That's the preloaded one. It goes to the place. As you can see, the flags that are shown there are the flags for every point of interest. We go, for example, here in Curthon Gate, and this app has the option to go to the place. It goes to the place, it loads the KML on the side with the information of this point of interest and others. And then when we stop in the Liquid Galaxy, we can do an orbit. It rotates around the point of interest. You can stop the orbit, and then the app also talks.
The Curthon Gate is a prominent landmark in Bardamans.
Then another thing that we can do is play the GeoGuessr game in this app. In this app is called GeoQuest. As you can see, we have here in this app is right now showing the map on the tablet, and when we move the map, as you can see, the map moves on the Liquid Galaxy. And we play start game, and we have to go to the United Kingdom to Cheshire Wales and Chester. We need to find it, and I'm going to go to somewhere else to show that the app actually locates you, says what distance are you from the actual place that you should be, and gives you a point in counting the distance. For example, we are really far away, so this is a mess. It says nice try, but you have 0 points. And then it goes to Italy. We'll go to Italy. In this case, I'm going to go decently near, so that we get some points. I messed up. I pressed the start again button. Easier enough. We press, and we are like 300 kilometers away, so we got 450 points. And if we go to the other parts, we got the KML maker. This is really useful because we can make KMLs from the app directly. In our case, we can make a straight point, just a marker to go to show where we drop it. You press submit data. In our case, we are in New York. The data shows here. You can edit the data. For example, instead of marker, we put D, the letter D. Add element, and we see the marker here. We can visualize, and then the LG moves to where we need to go. Then we can also do a line. The move here. This is the line that we will show a white line in the screen. You can add more points to the line, and for example, we can have a little L here. We submit the data, add the element, and visualize. And as you can see, we see the line. And the same for the polygon. It's like the line, but all the points connected with each other. Then we have the tour management. We can wait a bit because this is a different way. This is for us to not only be able to go to the point of interest, but to also save the tours that we create using this part of the app. And for example, that we want to go to this tour, we press, we have the tour, and we can start the tour. And it shows the 4 points that we selected in tour. And then the last part is the LG controller, and in this case is a way to control the Liquid Galaxy. Right now we are in the map here in the Liquid Galaxy lab here in Lleida, and as you can see, the Liquid Galaxy goes to the map. Move the map, and the Liquid Galaxy moves too. And using voice, you can use these commands to actually move the map. For example, if I say move up, I'll say it lower, move up, and it moves up. Stop, stop. And this is how we demo the app. We show the functionality, and then we film the app using the camera. And this is my work here in the Liquid Galaxy lab during this year's GSoC. So this is my main work. I also do a little bit of extra things that Andrew tell me. So I hope you like this video, and goodbye.
Hi, my name is Alejandro Marcos. This is my first year as a main mentor in Google Summer of Code. I was a contributor 2 years ago in Google Summer of Code, collaborating with Liquid Galaxy and getting a great job. It was a great experience for me that improved my career, and I wanted to help someone to get the same. So I have been mentoring Oscar, contributor to get a great job testing and uploading different apps. I think collaborate another time with Liquid Galaxy, Andreuibanez, and Google Summer of Code has been incredible, and I only want to say thanks.
Hello, it's Ryan here, demoing my final presentation for my Liquid Galaxy project for 2024 for GSoC. And yeah, my project is kind of split into 2 phases, which is like one was like a REST API to implement voice-to-voice features for a bunch of text-to-speech and speech-to-text models, so that users can integrate that into the application, as well as a Groq endpoint to help speed up the responses, as well as I have a very basic Flutter application that allows just to demo like kind of how the voice-to-voice flow works and what the application can be used for. Jumping straight into the code, we have our main file here. So initially we initialize all the context in the homepage and everything, and then the model that we're going to use for both speech-to-text and text-to-speech is actually DeepGram. So I think their responses are just very quick, and their model is probably the cheapest out of all the options I've discovered so far. And then we're also using Groq, which is an LPU to speed up our responses that we get from LLMs. So it will help a lot in the context that we're using it, because we're speaking voice to voice. So that ideally we'd want the responses to be as quick as possible. And we're also using the audio recorder package. So that is for us to, when we start speaking into the mic, it'll record the package, change that into text, and that data will be sent to DeepGram's speech-to-text API and then back after we get a response. So yeah, we're gonna initialize our DeepGram object, which is API key and our basic configuration, so like model, etc. Then toggle recording, because we only have one button here, it does both start and stop. So this is only just to check that one thing is being done at once, and every time you record, we'll take that and we'll get a transcribe record audio. And then so this function, if we scroll down, is going to actually take the audio file and then use DeepGram, and then this is where we pass it in. So So this function takes the audio and then takes it into a file, and then this takes that file and then chucks it into deepgram speech to text, and we get back a transcript as a result. And if everything works out correctly, then the transcript is not emptied and we get sent to Groq. So Groq, we're gonna take that text and then I pre-prompted it so that we get back a specific our answer in a specific format, which is longitude, latitude, as well as a response, so that we can take our coordinate and then our Liquid Galaxy application can take us to the location as we're getting our response back. And then so we're using the GEMMA 9B model, which is recently released. And then yeah, so we're gonna get back a response in a specific format, and then it doesn't, if it throws any errors, we'll cache that. And then if we scroll down here, so if the parse response does contain a valid longitude and latitude, hopefully, and we'll throw that into a function called move to location. So if I scroll down here, so that takes our KML file that I've pre-configured and then just throws a longitude and latitude value so that it goes to the specified location, and then it writes to the file in Liquid Galaxy and then executes that on the server. And then once we go back, so at the same time, it's also going to run the play text-to-speech function. So again, we're using DeepGram with the default model being the Aura Asteria in English. Then passing our DeepGram API key, and then it writes the final audio to an MP3 file. And then as soon as we get that file, we're going to use the audio player package to immediately play that file, so it has a full voice-to-voice experience. So, and then the rest of our application, I have a very simple help page file. There's nothing too crazy, it's very just simple. I just wanted to allow users to have some basic instructions, as well as how to get some API keys so that they can actually try the application. And if you go back to the settings, we have our connection manager page. So this is present in every Liquid Galaxy application. It's how we connect to our rigs to begin with, and passing like IP address, LG password and port, and the number of screens, as well as I added the 2 key features. So the way I did this was that I made a global variable so that it would stay persistent, so that the variables don't actually disappear between each time I switch pages. So you'll see, like if you go back to the code, you'll see stuff like global connection, and then we get our API key. So once it's defined once and user submits it, it will be present throughout the application. So then we can just pass in port and everything, and then we can disconnect. So our page is just a bunch of text boxes. So I have like what is it, username, password, port, etc., just to configure everything. And then once you connect, they will tell us that whether they're connected to our Liquid Galaxy successfully or not. But just to demo my voice application, so we can go ahead and ask something like, let's say, what is the best restaurant in France? So the audio was very quiet, but it was audible. But in the back, we get back a response saying, I asked what is the best restaurant in France. I get a response saying this is the best restaurant, and then the text-to-speech model also read that out loud. The audio is very quiet on the laptop, so it's very hard to hear, but it did play. And then it also navigated to the location in Paris, because that's kind of where we asked it to go. And then gives a general, like a panoramic view of how things work. And then that's kind of it for the basic Flutter application. And next we have our flagship application, which is my API. So it has a bunch of text-to-speech models. So I Dockerize it, so with the help of my mentor. So we get all our Docker set up. And then there's basic documentation. So pricing, I think, is a big thing. So if contributors kind of want to consider that into consideration before integrating anything, this is one very basic pricing documentation for all the models that I use. And then as well as the actual models themselves. So there's a bunch for speech to text that we use, as well as DeepGram speech to text with all the optional required and optional parameters, so that users can configure their API to however they want to use it. So then we have DeepGram, Assembly AI, and you have text to speech with the Google Cloud, 11 Labs, etc. And then Groq, which I think is very useful because it's just, it's free service for our use case and just very, very quick to get a response. So I have all the models for Groq, with including the very latest that came out, I believe, a month-ish ago. So GEMMA 2. And we have that as well. And then we have our API documentation, which helps users kind of get all their keys. So it's all the links, and then kind of set up their Google API stuff with their credentials, and then running the server. And then, so if I actually take the container and run it myself here, and we'll give it a sec. So it's gonna run the, so it's gonna be running the API in the backend, and then we can open a new terminal. Yeah, so a bunch of endpoints. We have the first one, speech to text, and then we have a post request, and then the route, and then the various headers, and then I give a very basic example of like a curl command. I'll just throw this in here. So what this is going to do is we're going to post to this speech to text route, and then for the model, I'm just going to use we're Google org, so Google Cloud speech to text, as well as we have our audio example wave file that I have on the directory. So if I just hit this, we'll get back a post response. It'll take some time. So it's going to take this audio, and then we're going to get back a response in text. So this audio is around 25 seconds long, and this is a configured transcript after reading it. This is through the Google speech to text, and this is indeed the same as the one in the example. And then let's clear this for a sec, and then we also have a text to speech. So this is also a post method, very similar. Instead, we pass in text, and we will get back an audio file. So raise the volume as high as possible. So we have our example curl command. If I just throw this in here, so in this one we're going to pass in model being Google Cloud text to speech, and instead of passing an audio file, we're going to pass in content. So the model is going to take this text, hello, this is a test message, and then convert it to an audio file. So if we send this request, get back a response, and here we have a newly generated Google Cloud text to speech. So if I try playing that,
hello, this is a test message.
So that is exactly the text that we passed in here. Hello, this is a test message. And then we go back, and then I'll clear this one more time. And then we have our last endpoint, which is Groq. So we'll pass in, this is just text to text. So we'll just make a curl command here. So this will take the content, hello, how are you doing today? I will ask the model of GEMMA 9B, and then get back a response. So if we ask this, so very, very fast. So it gets back a response saying, hello, how can I help you today? And as you can see, there's a very, get back different emojis and different text. So when kind of using my application, I filtered that out and parse that through so that it's correct. So this is kind of like my app. This is kind of basically my application. It's just a way for us to try to integrate voice-to-voice features in a very easy way, and for our Liquid Galaxy apps for current and hopefully the future as well. And I plan to continue to maintain this as as time goes on. But overall, I think GSoC has been definitely like a life-changing experience. I've got to meet very, very great people, not just the org mentors and like the admin, but also other contributors who are very passionate about building stuff and contributing to open source, just as myself. I think having this community throughout the whole summer, as well as continuing on, I think was a very valuable experience for me. We had a lot of opportunities to not just interact through like text and through Discord, but we had a lot of general meetings as well. I believe we had our 8th one today, so we had a lot of opportunities to kind of get to talk, not just about the project, but just about other stuff as well. So we had a lot of time to bond with each other. And I think the private mentorship that I got from Andrew and Moises and Oscar helping me with testing, I think was very valuable. I've definitely learned a lot. And I think this is something I definitely want to continue to contribute in the future. And that's kind of my GSoC summary. And I'm hoping many others in the server can perhaps start contributing themselves, and then maybe they'll be able to get into GSoC as well. And I think I would definitely encourage everyone to give it a try if they are passionate about it. But thank you.
Hello everyone, my name is Monsó, and this year I have been a GSoC mentor for projects related to artificial intelligence. This means that this year has been really special for me, because mostly of the project that has been created include artificial intelligence tools or models. This has been a great challenge for the students due to the complexity that sometimes arises when using LLMs in different kind of environments, for example, on-premise or cloud. And in my case, one of my students has been working on creating a tool that could be used for other students to use model capable of generating audio responses from an audio question. This is something really useful if you are trying to create a real interaction, for example, using a mobile phone with the Liquid Galaxy. And in this case, my student Ryan has worked somewhat intermittently, doing a lot of work in very short periods, which can sometimes complicate the use of his work by other students. In my opinion, this is something really important because GSoC is a real opportunity to carry out a project with well-defined milestones and goals that involve working every day to get closer to the goal, that is, finish the project on time. And documenting is a really important part of it because your project has to be evaluated and used by other students. Then, when you are facing this kind of project, a GSoC 1 for the summer, you have to be sure that you have the time that you need to solve the task that you are defining in your proposal and reach the goal on time.
Hello everyone, so this is the technical explanation for the Super Liquid Galaxy controller. So first of all, I would like to tell you what the main goals for my application were. The Super Liquid Galaxy controller was meant to be an overall all-encompassing controller for the Liquid Galaxy system. Now, there have been several iterations to create a proper controller for the Liquid Galaxy previously, but all of them have been focused on one particular feature while essentially ignoring others. What I wanted this application to be is basically condense all the different functionalities that one can expect while interacting with the Liquid Galaxy system and make them approachable in one master application, and that is the Super Liquid Galaxy controller. So if one wants to control the Liquid Galaxy system, they can use my application. If they want to create a tour, they can use my application. If they want to visit a certain POI, they can use my application. If they want to create custom KMLs, they can visit my application. So it kind of condenses all the different features, adds to them, enhances the different features, brushes them up, and condenses them into one concise and beautifully created application. And that is the Super Liquid Galaxy controller. Now let me move on and walk you through all the different features that my application possesses. So the first is the dashboard, of course. The dashboard, being the first screen that the user encounters, has to be beautiful, has to be interactive, and has to look the absolute best. So of course, created a beautiful UI for it, and it shows concisely all the different features that the user can use in one reach. So as you can see, there is a little planet selector right in the beginning. Then there is the settings screen. There is a clear KML right on the home screen, so that the user can clear any KML from the Liquid Galaxy. And then there are all the different features that are in my application. So let's go through them one by one. The first one is the custom KML builder. So this is a screen which allows the user to create their own custom KMLs using a very interactive map editor, and they can create any kind of polygons, lines, place marks, and visualize them in LG. And if they want, they can download that KML as a .kml file. So that is about the custom KML builder. Next is the map controller, which kind of gives us a very interactive way of controlling the Liquid Galaxy, where they can control it using map movements, and they can also use a voice command feature to control the Liquid Galaxy using voice commands. So the user can say move up, or move down, or zoom out, or zoom in to control the Liquid Galaxy. There is also a search by address, which kind of essentially eases the process of zooming into a particular location. Now the next application screen is the GeoQuest. So this is a very fun little simple game which allows the user to kind of explore how the Liquid Galaxy will be used. So it's very similar to GeoGuessr. You would have to place this pin on the given location and then put a guess, and it will give you a score according to that. It's a very fun game, surprisingly addictive, I would say. Next is the POI exploration. So this is one of the main features of my application, where the user would be able to visit any particular country and any particular state in that country and fetch all the different POIs in that state. And the user can then click on these POIs to kind of view all the different features, all the different main, so an image, a description, all the nearby places for that place. The user will be able to see all the details for that place. Next, moving on, is the tour management screen. So this is very similar to the POI exploration, but with the added benefit of being able to create interactive tours. So the user can add any POI to their tours, and one by one it creates a nice little interactive tour which the user can then play out on the Liquid Galaxy rig, and it shows a very nice dynamic KML with footprints between them, with airplane tracks, with road tracks between them, and a nice little walkthrough through all the POIs. So that's about the tour management screen. Finally, let me talk about the actual code of the application. First of all, I would like to introduce all the technologies that I used. Obviously, the application was created using Flutter and Dart, which is a departure from the previous main controller application, which is the located voice CMS, which was built in native Kotlin. So of course, Flutter and Dart gives us the opportunity of a much better UI. Next, we have KMLs. Of course, this is the main geo-visualization aspect of my application, allows us to create very nice geo-visualizations on the Liquid Galaxy rig. Then we have SSH, which my application uses to open a channel through which our Android application can communicate with the actual Liquid Galaxy rig. Next, we have GetX, which is the state management solution of my application, which introduces a very novel idea of controllers to kind of refresh the UI only when it is needed and only for the components that need the UI to be refreshed. Then we have Hive, which is a very fast NoSQL based database which stores values in key value pairs, and it can fetch data asynchronous without even needing asynchronous commands, so it is very fast. Then we have Google Maps, which obviously I have used for all the map based interactions in my application. Finally, the last two are the main information based screens of my application. So first we have GAPFI, which gives me all the information that my application is using. So for, let's say, for example, state boundaries, the POIs in those state boundaries, the nearby places, categorizing them, everything is handled by GeoAPI. And finally, to fetch information about each individual POI, I have used Wikipedia to scrape their data, scrape descriptions about them, and also scrape images for them. That is all about all the technologies I use. Now let us move on to the actual code for a bit. I'll just show you a very quick overview about how the code is structured. So of course, my code is separated into all the different components. So first of all, I have all the reusable components. So these are basically simple UI components that I've used for all of my screens. So as you can see, connection flag, coordinate field, these are all components that I've used over and over in my application. Then we have controllers. So this is the main component of GetX. So what this introduces is something called a GetX controller. What this allows us to do is create a singleton instance of a class, which allows us to create only one single instance that will be alive throughout the application. So for example, this LG connection handles all the SSH commands that are passed to the Liquid Galaxy rig, and we need that to be a single instance. So for that, we use a GetX controller. If you are familiar with Android terms, it's very similar to view model in the MVVM architecture. Now that the controllers are explained, let's move on to the data classes. So these are the main, you would say, entities that my application is creating. So these data classes represent the separate entities that my application is fetching or storing in my database or fetching from the API. Everything is stored using these data classes. So for example, if you look into place info, this is what is storing all the different info that can be required from a particular POI. Similarly, we have everything from wiki image data to wiki data to country data. So all of these are separate entities. Now that we have looked into the data classes, let's move on to the screens. So these are the main screens of my application, which the user will interact with. So as you can see, all the main features are located here. So dashboard, GeoQuest, KML builder, maps controller, place view, POI exploration, all can be seen here. Finally, there is another section called tabs. So these are all the tabs that were accessible in the settings screen. So this is a very simple idea. And finally, the most important, we have the utility functions. So these are the classes which are doing all the utility work in my application. So for example, let me just open KML generator. So this is the class which helps me generate all the different KMLs. So let's say I want to generate a blank KML, this function will do that. If I want to generate a place mark, this will do that. If I want to generate a custom KML, this will do that. So I have created modular functions for generating every kind of KML here. Similarly, I have balloon generator. Then I have a constants class which stores all the different constants that I have used in my application. So as you can see, everything is stored here. Then finally, we have the main POI description fetcher, which is for which I am using Wikipedia. So this uses these endpoints to fetch all the different data related to a POI. So for that, I use these functions. So as you can see, fetch image URL. This will fetch the images for that particular title. This will get the images for that particular title. And similarly, everything is fetched from this Wikidata fetcher, and that is rendered in my components. So that is a overall view about how my code is structured. Of course, a deeper insight into the code is given in my live code review, and I would love if you check that out. But that should be all about my application, and if there are any queries, I would love to answer them. Feel free to contact. Thank you a lot. Hello everyone, so this is the app showcase for the Super Liquid Galaxy controller. So this is the dashboard where we can change the planets if you want. So let's say I want to change to Mars. So I can just click there and it will change the planet on the Liquid Galaxy rig to Mars, right there. Now let me just, similarly of course, I can change the planet to Moon, but let's just change back to Earth. And I'll just quickly show you the settings screen. So right here, this is how we connect to the Liquid Galaxy rig. I have all the details given, so connection established. Similarly, this is all the SSH commands that we can give. This is where I enter the API key for the G85 Places API. And this is a simple about screen for information about my application. Now, let's move on to the actual screens. So first of all, we have the custom KML builder. So this screen right here allows us to create custom KMLs for our Liquid Galaxy rig. So let's say I click polygon, and this takes us to the polygon screen. And we can create any kind of custom KMLs using this map editor. So let's say I just create any kind of custom KMLs that I want, edit it as I want. These are drag and hold. These are hold and drag. And then I submit data. So all that data gets sent over to this editor, and if I want, I can add that element. Similarly, I can put any kind of line string, I can add any kind of points, and then add and then submit that data to this editor and add that element. Similarly, of course, we can go for a place mark. We can submit data, add that place mark, and that gets added to my KML file. Now, if I click on visualize in LG, it will take that custom KML file, create it, and then visualize it right over here. So as you can see, there's a polygon, there's a polyline, and there's the place mark. Now, if I want to download the KML file, I click on download KML file and it gets saved as a .kml file. Alright, so that's all about the custom KML file builder. Now let's move on to the LG controller. So this is a map-based controller for the Liquid Galaxy rig, and it allows us to control the Liquid Galaxy rig using map movements. So if I just zoom out, what you will observe is that the Liquid Galaxy rig basically mirrors the movements of my map. So if I move it to the right, the Liquid Galaxy rig will also move to the right. Simple as that. It also has a voice commands feature where I can use all of these commands to control the map. So let's say I say, alright, can you move up? So as you can see, the map starts moving up. Okay, you can stop. Alright, so as you can see, it stops, and of course the Liquid Galaxy rig mirrors that movement. Similarly, there are all these commands that I can use. Now, it also has a search feature, so if I want, I can search up any location. So let's say I click Howrah. As you can see, suggestions come in whenever I want. Say Howrah Maidan is what I want. Alright, so as you can see, whenever I click there, it takes me to Howrah Maidan. Alright, so that's all about the map controller, and as you can see, it's taking me to Howrah Maidan. So that's all about the map controller. Let's move on to the GeoQuest. So this is a simple Liquid Galaxy based game that we can use to kind of teach people how to use Liquid Galaxy. So whenever I click Start Game, it will give me a random location which I have to guess. So it's talking about somewhere called Ivory Coast. I actually have no idea where that is, so I'll just give it a random guess. And well, that was very far, so the score is 0. But that basically gives me a score based on how far I am from the location. Now it keeps going on. Now it asks me to guess something near Niger. So if I click there, yeah, so I get a score. So this was a correct guess, so I also get plus 500. So that's nice. So that is how I play the game. There's also a timer for each of these guesses. Alright, so now that that's done, let's move on to the POI exploration. So the POI exploration screen, also on every screen, I have a little showcase, which basically allows me to see what each of the component does, right there. So this screen allows us to view the POIs for any location, which is selected here. So by default, it's India, West Bengal. And of course, I can set it to anything using this screen. So if I want, I can select in country and I can go to that country. Alright. But let's just see India, West Bengal. Let's say I want to see Hazardwari premises. So I click on it and it will fetch all the information about that particular place. So this is the image of Hazardwari premises. This is all the information about it. This is all the nearby POIs, and I have an orbit and voice excerpt function. And of course, the Liquid Galaxy rig also shows all that information, and it takes me to that location. And there's also a bubble showing all that information. Now, let's say I want to orbit that place. I will click orbit, and the Liquid Galaxy rig should orbit the place. And I also have a voice excerpt feature, so if I want, I can make it read out this description. So,
Hazardwari Palace, alien is about
that. So now that that's done, I can click on orbit, so it will stop orbiting. And so that's all about visiting POI. Similarly, I can visit any POI that I want. Whenever I click back, it will take me to the overall location. Now that that's done, let's move on to the tool management part. So this is the final screen of my application, which has the most features, I would say. So as you can see, this is very similar to how our POI exploration looks. So this has the same POI exploration features, but I can also create tools using it. So let's say I want to visit Curzon Gate, and I take that and I click submit data. What that does is it adds it to my tool. Similarly, I can take this and add it to my tool, and take this and add it to my tool. So what that does is basically creates a tool for me, and I can visit that tool.
Now, of course, I also have the option of saving tools. So if I click add current tool, it will save this tool to my current location, the current one. Now let me just visit one of the tools. So if I click on that, it loads that tool right here. And when I click on start tool, the Liquid Galaxy rig will start showing me that tool. Now, as you can see, the first POI was Curzon Gate. So it will take me to Curzon Gate. And then after some time, it will start orbiting that. So after it has taken the time to zoom into that location, it will wait for a bit, and then it will start orbiting that place. So let us just wait and see the visualization. Basically, it will walk us through the tool we have created with proper visualizations between them, so that the distance is low. It will show footprints between them. If the distances are high, it will show a road track. If it's very high, then it will show an airplane track. I have explained all of that in my code review. So as you can see, it is currently orbiting this place. Once it finishes orbiting, it will take me to Dwadash Ship Temple. As you can see, that's the next place in my tool. So as you can see, it takes me there, and as you can see, these are the footprints that it's rendering. And it will take me to Dwadash Ship Temple. Whenever it starts orbiting, the footprints vanish, and it will only show me the current location that I'm trying to see, so that all this clutter won't be on the screen. So we'll just wait a bit for it to start orbiting, and whenever it starts orbiting, the footprints will vanish. So as you can see, the footprints vanish, and only the Dwadash Ship Temple stays, and it starts orbiting then. So that is all about my tool management screen, and this should do it for all the features of my Liquid Galaxy controller. And I hope that was a satisfactory showcase. Thank you.
Hello everyone, this is Aritra Biswas, and my project was the Super Liquid Galaxy controller. I'm here to talk about my experience with Google Summer of Code 2024. I want to say Google Summer of Code 2024 has been an extreme learning experience for me. It has taught me various things and helped me advance greatly in my software development career, and helped me grow as an open source contributor. It has allowed me to learn how to deal with things when working in a community. It has helped me explore various different tech stacks like KML visualizations, like working with SSH commands using in an Android application. These are territories that I had unexplored before I worked with Liquid Galaxy. However, Liquid Galaxy as a community, as a project, as an organization under Google Summer of Code has helped me through it all and guided me really well to the point that I have been successful in creating, I would say, a very well created application that I hope will help contributors in the future, will inspire future contributors like myself, and will provide a useful asset to Liquid Galaxy itself. The main challenges that I would say I have faced during Google Summer of Code is creating code that was on a level that could be deployed. Deployment ready code is very different from the general projects that we create by ourselves, and that was the main hurdle for me, to create code that was scalable, to create code that created outputs that were worthy of being accepted by an organization such as Liquid Galaxy. And although it was the most challenging part, it was also the most fun part of Google Summer of Code, since it's helped me learn and transform my passion for software development into an actual real life skill. And for that, I would like to thank my mentor, Yash, of course, organization leader Andrew sir, and everyone of the vibrant community of Liquid Galaxy. I hope I can keep working with you all in the future. Thank you.
Google Summer of Code mentor for 2024 at the Liquid Galaxy project. I have been seeing all the lovely contributors making such excellent projects and have been overseeing and monitoring all the user experience work specifically, and also all of the core functionalities, and that all the contributors are working really well. I just want to thank Aritra for his wonderful work, which is the Super Liquid Galaxy controller. He has found a very intuitive way to control Google Earth with the help of gestures, voice commands, and more. And I really like his attitude, his creativity, the way he proposed this particular original idea, and he is able to execute it successfully in this Google Summer of Code 2024. So I just want to say, through this journey, I'm really happy that all of the contributors so far have been succeeding in their particular projects, and I just hope them for the best, and I hope them best for the future endeavors as well. Thank you.